Hi guys. Tonight we drift together beneath a quiet, breathing sky. The air feels cooler than you expected, the kind that settles softly on your skin and hushes the world around you. Overhead, the stars shimmer in a pale river of light, subtle, endless, serene. It's the Milky Way, the home you've lived in all your life, though you rarely think of it that way. It arches above the horizon, like a ghostly band, a pattern your ancestors once used to navigate oceans, to tell stories, to imagine gods. You probably wouldn't notice it if you walked past it on an ordinary night, your mind full of earthly things. But once you stop, once you lift your eyes and let the darkness breathe, the galaxy itself begins to whisper. So, before you get comfortable, take a moment to like the video and subscribe, but only if you genuinely enjoy what I do here. And if you're listening somewhere far away, post your location and your local time below. It's always beautiful to see how the same sky stretches over so many lives at once. Now, dim the lights, flow straight into the story. You breathe slowly as your eyes adjust and the Milky Way brightens. To most people, it's just a smudge of silver, but tonight you start to notice detail, a grainy texture, like mist made of glitter. Every speck of that glow is a star, and each star is a Sunday. Some burn fierce and blue, some soft and gold, and some are already dead, their light still crossing the dark years toward you. Scientists estimate there are more than 100 billion of them bound together in this spiral sea. It sounds unfathomable, but if you look long enough, the numbers become something you can almost feel rather than count. The galaxy hums like a vast machine, ancient but still running. The Milky Way isn't just a picture in the sky. It's a real place, an enormous disk of stars, dust, and invisible matter stretching 100,000 light-years across. If you could see it from outside, it would look like a glowing whirlpool, its arms curling outward in delicate spirals. But from where you stand, inside one of those arms, you see it edge on a luminous band cutting across space. You are part of it, orbiting gently through its light. You think about what that means. Every breath you take, every heartbeat, happens on a planet that circles a star, that circles the galaxy's center. The motion is constant, though you never feel it. Right now, you're moving at over 200 kilometers per second around the core. That's fast enough to cross an entire continent in less than a minute. Yet everything feels perfectly still. The gravity of the galaxy holds you steady, wrapping you in the slow rhythm of its turn. A soft breeze brushes past, and you imagine the invisible forces at work above you. Gravity binds every star, every planet, every dust grain. Without it, the galaxy would unravel, like smoke. But gravity isn't alone. The Milky Way also contains something we can't see, dark matter, an invisible mass that outweighs everything else many times over. Scientists still wonder whether dark matter is made of undiscovered particles or something stranger, something we haven't even thought to name. Whatever it is, it acts like the skeleton of the galaxy, keeping everything from flying apart. You feel a strange comfort in that thought, the unseen holding the seen in place. Somewhere near the center of all this, about 26,000 light-years away, lies a point of darkness so dense that not even light escapes. A supermassive black hole, millions of times heavier than the Sun, quietly anchors the Milky Way's core. Around it, stars race in tight, dizzying orbits. Gas clouds spiral inward and vanish. Yet from this immense violence comes stability. The black hole's gravity helps orchestrate the motion of everything else. You can't see it from here, but its presence is felt in the slow, orderly turn of the galaxy. You blink, and the sky seems deeper now. Between the bright stars lies a faint dusting of darkness, cloudy lanes that twist through the band of light. Those aren't gaps, but clouds of interstellar dust, tiny grains of carbon, ice, and rock that absorb starlight. They look like shadows, but they are nurseries, Inside those cold veils, new stars are forming, still hidden from human eyes. Telescopes tuned to infrared light can see through the dust, revealing glowing embryos of suns surrounded by swirling disks of gas, future solar systems waiting to be born. The thought settles on you like a lullaby. Every star you can see was once hidden like that. Even the sun was once a whisper of dust, collapsing under its own weight, sparking into fire. And somewhere, in those same dusty regions, the next generation is waiting. You begin to realize the galaxy isn't static, it's alive, in its own slow way. It grows, changes, consumes, and creates. Above you, faint meteors scratch the sky. They burn out almost instantly, but their trails shimmer like threads tying you to the wider universe. It's strange how peaceful destruction can look from this distance. Even stranger to know that your atoms, carbon, oxygen, iron, were once inside such explosions. Every element heavier than helium was forged in a star's heart and scattered across space when that star died. The iron in your blood was born in one of those deaths. You carry starlight in your veins, remnants of things that burned long before Earth existed. Somewhere deep in the distance, a pulse of energy travels cosmic rays from a supernova, maybe, or the fading echo of a collision between black holes. You can't hear it, but if your ears could catch such frequencies, the universe would never be silent. Scientists still wonder whether this constant cosmic hum carries patterns, messages, or rhythms that connect everything. You let the idea drift for a moment, how even silence could be filled with meaning. The Milky Way's spiral arms extend like vast rivers of stars, each one curving around the center in a slow, graceful dance. The arm you inhabit is called the Orion Spur, a small lane between larger highways of starlight. It's a calm neighborhood, a place where radiation is gentle and catastrophic events are rare. Maybe that's why life found time to grow here, quietly, undisturbed. If Earth had formed closer to the core, you might be surrounded by chaos, supernova shockwaves, black hole outbursts, lethal rays. But here, on the edge of a peaceful arm, there was room for oceans and seasons and sleep. You tilt your head back and imagine what it would look like if you could rise above it all. The galaxy would stretch below you like a luminous whirlpool, silver and blue, with a glowing center and dark gaps where dust swirls thick. From that height, even the entire solar system would vanish to a point too small to see. Yet down here, you are the one who can think about it, describe it, feel awe at its scale. Somehow, consciousness has bloomed within the very galaxy it tries to understand. You let your breath slow again. The more you look, the more the Milky Way feels like an ocean, waves of light, tides of gravity, quiet depths that hide mysteries still unsolved. Scientists still wonder whether galaxies have hearts that beat cycles of brightness and darkness tied to the feeding of their central black holes. Perhaps somewhere far away, another spiral like ours has just awakened, its center blazing. Or maybe, like ours, it rests for now, spinning slowly in the dark. The night deepens, and your body feels weightless. The idea that you are moving, really moving through space becomes oddly comforting. Every second, the Earth spins, the Sun pulls you along its orbit, and the Milky Way itself drifts through the larger cosmos. You are part of all that motion, part of a living pattern that will continue long after your lifetime. Nothing stands still. Nothing truly ends. The stars shimmer one last time before your gaze softens. Somewhere in that distant haze lies the beginning of our story, a galaxy built from collisions, shaped by time, carrying within it every element of your world. The Milky Way watches over you tonight, not as a distant thing, but as the luminous home you've always belonged to. You drift deeper into the thought that the Milky Way isn't a single creation, but a patchwork of countless collisions, an enormous cosmic quilt, sewn together by gravity and time. From a distance, it may look serene, a perfect spiral suspended in silence. But the stillness is only an illusion. Every swirl of starlight hides an ancient story of impact, destruction, and rebirth. The galaxy you call home is built from the remains of smaller ones, long devoured and reshaped. If you could rewind cosmic time, you'd see chaos. Clouds of gas and dark matter colliding, dwarf galaxies drawn in and stretched apart, their stars spilling like golden sand into the void. The Milky Way, in its infancy, was not the graceful structure you see now. It was a restless storm. Slowly, over billions of years, gravity gathered the wreckage, flattening it into a spiral disk, spinning faster and faster until order began to emerge. And yet, even now, that hunger hasn't ended. The Milky Way is still feeding. One of its current meals is a small companion known as the Sagittarius dwarf galaxy. You can't see it with your eyes, but it's there, orbiting the Milky Way's halo, being torn apart piece by piece. Each pass around our galaxy stretches it thinner, scattering its stars into long tidal streams that wrap around the disk like threads of silk. These streams, faint and ghost-like, trace the paths of ancient collisions. They remind scientists that galaxies are not gentle neighbors. They are hunters, bound to consume in order to grow. Scientists still wonder whether this endless cycle is necessary, whether a galaxy could thrive without swallowing others. Some simulations suggest that mergers ignite star formation, shaking up dormant gas and lighting new generations of suns. Others show that too much violence can strip a galaxy of its fuel, leaving it barren and dim. The truth may lie somewhere between, a balance between chaos and creation. You imagine the Milky Way as a living rhythm, expanding and settling, feasting and resting, over eons too vast for human reckoning. Far off in the dark, the next great collision is already on its way. The Andromeda Galaxy, another majestic spiral, is drifting toward us. Its light reaches your eyes tonight as a faint smudge in the constellation of Andromeda, a ghost from 2.5 million years ago. It's moving closer at about 110 kilometers per second. That sounds fast, but in the cosmic scale, it's a slow embrace, unfolding over billions of years. When the two galaxies finally meet, their stars will not crash into one another directly. Space between them is too vast, but their shapes will warp, twist, and merge. A ballet of gravity, slow and soundless. When that time comes, the night sky will be unrecognizable. Future beings, if any still exist on Earth or elsewhere, will see Andromeda swell and stretch until it fills the heavens. Over millions of years, the two spirals will fold together, forming a single, larger galaxy, perhaps an elliptical one, pale and smooth, glowing with the combined light of trillions of stars. Scientists already call this hypothetical future Milkomeda. It sounds almost whimsical, but it's inevitable, as certain as dawn. The Milky Way, like every living thing, will transform. You let your imagination float through that distant epoch. The stars you see tonight will be gone or scattered. New ones will flare to life in the turbulence of merging clouds. The core will blaze as black holes spiral together, releasing waves of energy across space-time itself. To any quiet observer in that future, the universe will seem alive in ways we can barely imagine now. Galaxies aren't static portraits. They're stories in motion, changing shape even as we look at them. Closer to home, the remnants of past mergers still circle us. Streams of stars arc high above and below the galactic plane, ghosts of devoured companions. The Gaia Space Observatory has mapped some of them in exquisite detail, revealing patterns of motion that don't match the Milky Way's usual flow. Each pattern is a signature of collision, the mark of a smaller galaxy torn apart and absorbed. One particularly large merger, called Gaia Enceladus, or the sausage, happened about 10 billion years ago. Its debris reshaped the very core of our galaxy, thickening the disk and stirring its early stars into new orbits. It's strange to think that our serene night sky, the one you use to dream and rest, is the product of ancient violence. Every tranquil glimmer has been through upheaval. Even the sun may carry atoms that once belonged to other galaxies, drawn in during those chaotic years. You can almost feel that mixture in yourself, a trace of something older, beyond human ancestry, beyond Earth. The galaxy's blood runs through you. Above you, the Milky Way looks timeless, but its face is always changing. Over millions of years, gravitational tides pull and twist it like dough. Dark matter halos from other galaxies brush against ours, subtly altering its spin. Some regions compress and brighten, others stretch thin and fade. Even now, scientists detect ripples moving through the galactic disk, like waves on a pond after a stone has fallen. The cause might be a passing dwarf galaxy, or perhaps something even more mysterious, an unseen mass drifting nearby, disturbing the fabric of the Milky Way itself. The thought humbles you. The galaxy isn't a monument, it's an ongoing conversation between gravity and time. Each collision adds a new word to that story, each stream of stars another line of poetry written in motion. When astronomers chart the sky, they aren't just making maps, they're reading an autobiography, billions of years in the making. And you, for this brief human moment, are part of the latest page. The breeze shifts again, and you picture the Milky Way's future. After its merger with Andromeda, the night sky will no longer hold a narrow band of light. Instead, an immense glowing cloud will dominate every horizon, filled with billions of suns. Perhaps by then, humanity, or whatever follows, will no longer live on this fragile planet. Perhaps they'll drift among those stars, remembering how their ancestors once gazed from a small world and dreamed of belonging to something greater. Scientists still wonder whether galaxies feel the echoes of their past, whether the patterns of new stars are shaped by the memories of old collisions. It sounds poetic, but in a way it's true. The chemical makeup of the Milky Way's stars tells the tale of every merger, every feast. Some stars are rich in metals, born from recycled material. Others are pure, ancient, forged from the pristine gas of the early universe. Each one is a word in a language of light, recording not just where, but when it was made. You feel yourself growing lighter as you picture it all: the spiraling arms, the invisible dark matter halo, the faint trails of destroyed galaxies curving through the void. The Milky Way is not a peaceful home after all. It is a survivor. Yet within that vast, tumultuous body, you find peace. The stars may collide and merge, but from those collisions come beauty, order, and light. Out of cosmic chaos, harmony emerges. And as you breathe out slowly, you realize you've always been part of that pattern. A single life resting quietly inside the galaxy's endless motion. You drift onward through the dark, following the shimmer of scattered stars that seem to pulse like distant memories. The galaxy around you begins to feel older, its light softer, its colors cooler. Somewhere beyond the visible spiral arms, in the halo that envelops the Milky Way, ancient suns wander in long, tilted orbits. They are relics of a time before the Milky Way took its present shape. Some of them are so old that they were already shining when the galaxy itself was just beginning to form. These are the elder stars, the first lights of our corner of the universe. Imagine one of them. It glows faintly red, its surface calm, its composition simple, mostly hydrogen and helium, with almost no trace of heavier elements. Astronomers call such stars metal poor, but that name hardly captures their purity. They are survivors from the universe's childhood, forged in a time when there was almost nothing but the light of creation and the breath of expansion. These stars drift far above the galactic plane, solitary and dignified, like monks who have outlived their temples. Scientists still wonder whether some of these halo stars were born inside the Milky Way or were captured from smaller galaxies that merged into it long ago. Their chemistry, preserved like fossils in their light, holds the clues. When astronomers analyze their spectra, they find only faint lines from elements such as iron or carbon, proof that these stars formed before supernovae had time to enrich the universe with heavier matter. Each one, in its quiet way, tells a story about the dawn of time. You imagine floating near one of these ancient suns. Its light is gentle, almost tired, yet it has been shining for more than 13 billion years. Around it might circle a few dim companions, perhaps remnants of planets, perhaps nothing at all. Space there is thin, cold, and nearly empty. The Milky Way's bustling spiral arms lie far away, out of sight, beyond clouds of hydrogen and dust. Here, in the galactic halo, time feels slower. The stars move on, elongated, tilted paths that take hundreds of millions of years to complete. They travel so far from the center that gravity itself seems to loosen its grip. Some of these halo stars even predate the Milky Way's own disk. Long before the galaxy flattened into a spiral, before the Sun and the Earth existed, the early universe gave birth to small, irregular clumps of stars, protogalaxies, that would later collide and merge. The stars that formed in those early clumps now drift like ghosts around the Milky Way, reminders of what came before. If you could trace their paths backward, you'd be looking at the galaxy's blueprint, drawn in light. The oldest known among them might be nearly as ancient as the universe itself. It shines faintly in the constellation Hydra and is known as SMSS J031300. It contains almost no metals, just hydrogen, helium, and a whisper of calcium. Its composition suggests it formed from the ashes of the very first generation of stars, long before the Milky Way had gathered its mass. To think of it still burning is to realize how long the universe has been awake. You breathe slowly, imagining that first era. After the Big Bang, the cosmos was simple: hydrogen, helium, and darkness. Then gravity began to pull matter into knots. The first stars were born enormous and unstable, living fast and dying young. Their death scattered the first heavy elements, iron, oxygen, carbon, into space, creating the raw materials for planets and life. Those early explosions lit the night for the first time, and from their debris came the seeds of galaxies. The Milky Way is a descendant of that lineage, a continuation of that initial spark. Scientists still wonder how many of those first stars survived, if any. Some models suggest that all of them were too massive to last. They burned out in mere millions of years. Others propose that a few smaller ones, like hidden embers, may still exist somewhere in our halo, faint beyond detection. If one were found, it would be like finding the universe's first heartbeat still echoing through time. The search continues, through telescopes that can read the faintest traces of starlight. Back near the galactic center, newer stars blaze bright and blue. But here on the outskirts, the light is gentler. You can feel the age of this region, the way it holds stillness, the way old forests hold silence. Every atom here has been through cycles of birth and death, yet these particular stars remain untouched, unchanged, since before the Milky Way settled into its spiral rhythm. To see them is to glimpse the memory of the universe itself. The halo isn't a uniform shell, but a vast, diffuse ocean of stars, globular clusters, and invisible dark matter. Its structure is still a mystery, some parts thick with old light, others nearly empty. Scientists still debate how large it truly is. Some estimates stretch hundreds of thousands of light-years from the galactic center, possibly merging into the halos of neighboring galaxies. Out there, in those dim reaches, the Milky Way begins to blur into the cosmic web, the vast network of filaments connecting all galaxies. You realize that even at the edges, the Milky Way isn't isolated. It's threaded into something larger, a pattern that extends across the universe. You drift lower again, toward the galaxy's plane, and notice the difference in light. Younger stars shimmer here, rich in metals, born from material recycled over billions of years. Their existence depends on the elders above you, the ancient ones that forged the elements needed for worlds and life. Without those first generations, there would be no oxygen to breathe, no iron for your blood, no silicon for the rocks beneath your feet. Every part of you is connected to them. The thought fills you with quiet gratitude. You, a human lying on a small planet circling a modest star, are made of the same atoms that were born before the Milky Way even existed. Those atoms have wandered for eons through supernovae, interstellar dust, and collapsing clouds before finding their way into you. You are, in the most literal sense, ancient. You are part of the galaxy's memory. If you listen carefully, you can almost hear it, the faint hum of cosmic history, older than the galaxies, older than light itself. The Milky Way carries that hum within every one of its ancient stars. And tonight, as you drift between wakefulness and rest, you are close enough to feel it too. The elders shine above you, steady and unhurried, whispering that everything, no matter how young or brief, belongs to something timeless. You glide onward through the galactic sea, following a slow, unseen current that carries you closer to home. The light around you begins to swirl into a graceful rotation, an invisible rhythm you can almost feel. You are circling the center of the Milky Way, just as the sun and every other star does, bound to the great spiral's pull. This is your orbit, your silent journey through cosmic time. Astronomers call it a galactic year, and each one lasts about 225 million Earth years. One revolution of the galaxy, a single lap in an eternal dance. You let that number settle into your mind. 225 million years. When the sun last completed a full orbit, there were no humans, no mammals, not even the continents you know today. The supercontinent Pangaea had just begun to break apart, and the first dinosaurs were rising from the dust. Every mountain, ocean, and living thing you see now has formed since then. Earth has never returned to the same position twice. Every moment of history, every breath ever taken, has happened at a new point along the galaxy's track. You picture the solar system as a small cluster of travelers, drifting together through the spiral arm. The planets revolve around the sun around the galaxy, and the galaxy itself around something even greater, a vast gravitational web linking galaxies into clusters. It's motion within motion, a layered dance that never pauses, yet you never feel any of it. The air around you is calm, the ground steady. The galaxy moves with such smooth precision that, from your perspective, it feels like stillness. The path of the sun through the Milky Way isn't a perfect circle. It weaves slightly up and down through the galactic plane, rising and falling every 30 million years or so. Like a slow wave, the solar system bobs through the sea of stars. Some scientists have wondered if this motion affects life on Earth, if those times when the sun drifts above or below the plane might expose the planet to extra cosmic radiation, influencing evolution or even extinction. There's no certainty, but it's an intriguing thought, that the rise and fall of the solar system could shape the flow of life itself. Right now, as you read these words, you are moving at nearly 230 kilometers per second around the Milky Way's center. In the span of a single heartbeat, you've traveled farther than the length of your city. In a single day, you've swept millions of kilometers through space, but everything around you, Your room, the trees outside, the moon moves with you, bound by the same gravitational grip. That's why you don't feel it. You are part of the motion, carried effortlessly by the current of the galaxy. Scientists can trace this movement using precise instruments, measuring how stars drift over years and decades. They've learned that not all parts of the Milky Way rotate at the same speed. Near the center, stars whip around in tight, rapid orbits. Farther out, like the sun, they move more slowly. But here's the mystery. The outermost stars orbit far faster than they should. According to Newton's laws, they ought to slow down, just as planets farther from the sun move more slowly. Yet they don't. Something unseen, something massive holds them in place. That something is dark matter, the invisible glue of the cosmos. It's as if the galaxy wears a cloak of shadow, heavier than all its stars combined. Scientists still wonder what dark matter truly is. Is it made of undiscovered particles, or is our understanding of gravity itself incomplete? Every orbit, every rotation of the Milky Way keeps that question alive. Without dark matter, the stars at the edge would fly away into space. Because of it, the galaxy remains whole. You imagine this invisible force encircling you as you drift, a soft, unseen tether holding every star together. There's comfort in that, the knowledge that even the unseen has purpose. As the solar system travels, it doesn't stay in one part of the galaxy forever. Every galactic year, it winds through different regions, quiet stretches filled with dust, bustling arms where new stars are born, corridors of calm and turbulence. The light you see in the night sky is constantly changing, even if it takes millions of years for the pattern to shift. The constellations humans draw, the hunters, dragons, and queens, are temporary. Slowly, silently, the stars drift. The sky of the future will be unrecognizable. You picture Earth during one of its earlier laps around the galaxy. The world was warm and lush then, ruled by reptiles with feathered wings. Giant trees towered over swamps, and seas shimmered with ammonites and fish that no human eye would ever see. Above them, the same Milky Way arched across the night, different in shape, but still luminous. The dinosaurs never knew they were orbiting a galaxy. They simply existed within it, as you do now. Each orbit brings the solar system through regions of different density, like swimming through invisible tides. Sometimes the path carries you closer to the galactic center, where stars are dense and radiation fierce. Other times, it lifts you outward into quieter lanes of space. These cycles may influence the rhythm of comets that pass through the solar system, or the amount of interstellar dust that drifts toward the Sunday. The galaxy is not uniform. It breathes in vast patterns, and you move through its inhale and exhale. Astronomers have traced this path using precise data from missions like Gaia. They can see the sun's orbit curve gently through time, looping through the spiral arm known as the Orion Spur. It's not one of the grand arms like Perseus or Sagittarius. It's a small bridge between them, a calmer place. Perhaps that's why life was able to arise here, in this pocket of cosmic quiet. In more chaotic regions, constant supernovae might have sterilized worlds before they could bloom. Here, the pace is slower, the light softer, the conditions just right for a small planet to nurture thought. You feel the rhythm of that motion, not as movement but as a presence. It's like the slow heartbeat of the cosmos, too vast to sense directly but always there. Every sunrise and sunset is a tiny tick in that immense clock. Every lifetime, a fleeting second in the galactic year. You, and everyone you know, exist in the blink of the Milky Way's turning. Scientists still wonder how long this graceful motion will last. In about 4.5 billion years, our orbit will bring us close to Andromeda, and the two galaxies will merge. By then, the sun may be nearing the end of its life, its light fading to a red glow. The sky will bloom with new stars and collisions. But Earth may already be gone, folded into the next generation of worlds. It's a distant fate, yet somehow it feels peaceful. The galaxy doesn't end, it transforms. You drift through that vision like a leaf carried downstream. Around you, the stars move together, patient and sure. Each one follows its own path, yet all are bound by the same center, the same invisible thread. You are part of it too, sharing in the Milky Way's grand orbit. The galaxy turns, and you turn with it. There's no destination, only motion, smooth, endless, and beautifully silent. You drift farther along the galactic curve, feeling as though the night itself is breathing beside you. The Milky Way, though ancient, isn't finished. It's still growing, still changing, still pulling the universe toward it, grain by grain. You imagine the galaxy as a great living organism, not alive in the way you are, but in constant evolution. Over billions of years, it has expanded its luminous arms, drawn in smaller companions, and absorbed their light into its own. The process hasn't stopped. Even now, in the silence between stars, the Milky Way continues to gather. Some of that growth happens quietly, through invisible rivers of gas flowing in from the space beyond. These filaments, part of the vast cosmic web, stretch between galaxies like strands of silk. They carry hydrogen, helium, and traces of other elements, raw material for new stars. You picture them as transparent streams, slowly feeding the Milky Way from all directions, replenishing what time and creation consume. The galaxy drinks from the universe, the way a tree draws water from soil, patiently, invisibly, without ever stopping. Every so often, this steady rhythm is disrupted. A dwarf galaxy strays too close, caught by the Milky Way's gravity, and begins to unravel. Its stars spill outward, wrapping themselves around the larger galaxy in shimmering arcs. You might not notice it from your vantage point on Earth, but telescopes can see these trails, thin ribbons of starlight, looping through the dark like veins of gold. Each one is a sign that the Milky Way has eaten again, adding new members to its sprawling family. Scientists still wonder how much of our galaxy was built this way. Some computer models suggest that up to half of the stars you see may have come from other galaxies, pulled in and mixed over eons. Others propose that most of the Milky Way's growth comes from the slow condensation of gas rather than mergers. The truth, perhaps, is a balance of both an endless conversation between collision and calm, chaos and creation. Whatever the method, the result is the same. The Milky Way is still assembling itself piece by piece. High above the galactic plane, faint clouds of hydrogen drift in from the void. They move slowly, like mist across a dark ocean, until gravity catches them. Some fall inward, heating and compressing as they descend. Others are deflected or torn apart by magnetic fields before they reach the disk. Astronomers call these the high-velocity clouds, and they are among the galaxy's quiet suppliers of fuel. No one knows exactly where they come from. Some might be leftovers from ancient collisions, others fresh material from the intergalactic medium. Each one is a drop in the vast reservoir that keeps the Milky Way alive. In your mind's eye, you travel along one of those invisible streams. It stretches for millions of light years, its particles sparse but steady. Along the way, you see galaxies scattered like glowing islands, each with its own inflows and outflows, each connected to the cosmic web that binds the universe together. The Milky Way is not isolated. It's one node in a grand network, part of an ever-expanding structure that stretches beyond imagination. Even the empty space between galaxies is not truly empty. It hums with energy, gas, and dust that wander between the stars. As you drift back toward the Milky Way, you see that growth is not always gentle. Some regions of the galaxy show scars, ripples in the disk, warps along the edges, trails of stars pulled far from home. These are the fingerprints of past encounters. A passing galaxy may have brushed against the Milky Way, tugging on its outer stars, bending its structure slightly out of shape. Over millions of years, those disturbances become part of the pattern, woven seamlessly into the spiral's motion. The galaxy heals itself, but the memory remains. Closer to the core, where stars crowd thick and gravity is strong, new bursts of creation ignite. Clouds collapse into clusters, lighting the arms with fresh fire. Each generation of stars enriches the next, scattering heavier elements into the interstellar medium. That's how galaxies grow richer over time, not just in size, but in complexity. The Milky Way you live in today is not the same one that existed when the first oceans formed on Earth. It has evolved, brightened, deepened in chemical diversity. It has matured, like a living being slowly aging into wisdom. You let your thoughts follow one of those new stars, a bright young sun born from the collapse of gas. Around it, dust gathers into a disk, spinning and clumping into worlds. Somewhere out there, a planet like Earth might form, orbiting quietly in the warmth of that newborn light. The ingredients for life, carbon, oxygen, water, come from older stars that lived and died long before. In this way, the Milky Way keeps creating not just stars, but possibilities. Its growth isn't only physical, it's creative. Every breath of stardust could be the start of another story. Scientists still debate how long this process can continue. The galaxy's supply of gas is not infinite. Over time, as it forms more stars, the raw material becomes scarcer. The pace of creation slows. Already, astronomers believe the Milky Way has passed its peak of starbirth. It's entering a quieter era, where growth happens less by fire and more by absorption. But even in stillness, it continues to change. It is never done. You imagine yourself looking down at the galaxy from above, watching its arms curl slowly in motion. From that perspective, the Milky Way resembles a vast whirlpool, drawing everything toward its luminous center. Stars drift inward, gas flows along the arms, and dark matter wraps around it all like an unseen tide. The structure looks serene, but it is alive with motion. You can almost feel it breathing. Inhale, exhale, creation, rest. In the calm between those breaths, you find your own rhythm slowing to match. Your heartbeat falls into step with the galaxy's turn. You think of how much time must pass for it to change, billions of years for one cycle of growth, billions more for its quiet decline. And yet here you are, conscious for a brief moment within that eternal span, witnessing a living universe. The Milky Way grows without intention, without need, and yet it creates beauty effortlessly. It doesn't rush, it doesn't worry, it simply continues. You let that truth settle over you like the faint glow of starlight. Everything around you, from the smallest atom to the greatest spiral, is in motion. Growth doesn't mean hurry, it means becoming, at whatever pace the universe allows. As the Milky Way turns, you drift with it, part of its deep and unending breath. The galaxy grows, and you, tiny but luminous in your own way, grow with it, folded into its slow expansion, a single spark carried within its infinite calm. You glide through a river of faint starlight, deeper into the Milky Way's luminous spiral arms. They stretch outward like the curved petals of a vast cosmic flower, glowing softly against the darkness. Each arm is a band of stars, dust, and gas, winding gracefully around the galactic center. You can trace their gentle arcs, but soon realize something curious. The pattern isn't as neat as the pictures you've seen. The arms twist and branch, splitting like veins under translucent skin. Some fade, some reappear, some blur together, where gravity and motion weave unpredictable shapes. You might think that astronomers, after centuries of study, would know exactly how many spiral arms the Milky Way has. Yet even that simple question remains a mystery. For decades, the answer was 4. Later, some claimed there were only 2 major arms. Others argued for a hybrid pattern, 2 grand spirals connected by smaller fragments and spurs. From inside the galaxy, where you live, it's almost impossible to tell. You can't step outside to look down on the Milky Way from above. Dust clouds block the view, and starlight blurs in the distance. Even with the finest instruments, the map of our own home remains incomplete. Scientists still wonder whether the Milky Way's spiral structure is fixed or fleeting. Some theories suggest that the arms are long-lived features, anchored by density waves, ripples in gravity that move through the galaxy like traffic jams of stars and gas. Others propose that the arms are transient, forming and fading as new stars ignite and die. The truth may lie somewhere in between, the arms shifting gently over millions of years like patterns in flowing water. Nothing in the galaxy is perfectly still. Even the shapes you think of as eternal are slowly rewriting themselves. You drift into one of these arms and feel its texture change. The light here is warmer, more crowded, filled with the gleam of young stars. The airless space between them seems alive with dust and gas, the raw material for new suns. Clouds coil like slow smoke, glowing faintly with reflected light. Within them, gravity begins its patient work, drawing matter together, grain by grain, until collapse becomes inevitable. Soon, hidden inside the densest knots, nuclear fire will spark, and a new generation of stars will blaze into being. These luminous clusters illuminate the spiral arm like lanterns along a riverbank. A single arm can stretch tens of thousands of light-years long and 1,000 light-years thick. It moves not as a rigid structure but as a flowing wave, with stars entering and leaving over time. The Milky Way's rotation ensures that the arms don't drift apart. Each one is a harmony of motion, stars orbiting at different speeds, but together forming the illusion of permanence. You might think of it as music, slow, cosmic music whose notes are suns, whose rhythm is measured in millions of years. As you move along the spiral, you notice color shifts. Blue stars, massive and young, burn fiercely and die quickly. They mark regions of recent creation, stellar nurseries where clouds have only just ignited. Further along, the light softens to gold and red, where older stars linger. These subtle gradients trace the history of time written into the galaxy's shape. Every spiral arm is both past and present, fresh beginnings braided with ancient ends. If you could stand outside the galaxy and watch it turn, the arms would appear to sweep through space like slow whirlpools. But from within, the movement is deceptive. The stars themselves don't stay fixed inside the arms. They flow through them. It's like driving through a rainstorm. The raindrops seem to form streaks around you, but each drop moves on its own path. The spiral arms are patterns, not objects. They're choreography rather than structure. The galaxy doesn't just rotate, it dances. Scientists still debate how the Milky Way's spiral pattern began. Was it triggered by ancient collisions with smaller galaxies, each one sending ripples through the stellar disk? Or did the arms emerge naturally from the self-gravity of rotating stars and gas? Some computer simulations show that the arms can form spontaneously, like eddies in a river, and then fade as quickly as they appear. Others suggest that the central bar, an elongated band of stars crossing the core, acts like a metronome, driving the arms outward with rhythmic precision. Whatever the cause, the result is one of nature's most elegant forms, a spiral, repeated across galaxies like a universal signature of order within chaos. You pause in a quiet stretch of the arm, where the stars thin out and dark filaments of dust thread between them. The view is hauntingly beautiful, ribbons of shadow against a glowing background, like calligraphy written on silk. The dust is not empty, it is alive with chemistry. Within those microscopic grains are carbon compounds, ices, and silicates, the seeds of planets, the ingredients of life. Every world that has ever existed began as part of such a cloud. You're surrounded by potential, unlit, and waiting. Farther away, regions of turbulence shimmer faintly in radio light. These are remnants of supernovae, stellar explosions that once enriched the gas with heavy elements. The energy from those deaths stirs the surrounding matter, compressing it into new clouds. Creation follows destruction endlessly. You realize that the spiral arms are more than patterns of light. They are factories of renewal. The galaxy builds itself anew, turning the ashes of old stars into the fuel of future ones. The Orion Spur, the small branch of a larger arm where you live, glides past beneath you. It's a modest lane compared to the grand structures of Perseus and Sagittarius, but it's home. In its quiet, sheltered streams, radiation levels are low, supernovae rare, and star formation steady but gentle. Perhaps it's no coincidence that life emerged here. The Milky Way, in its vastness, offers both storm and stillness, and Earth found its place in the calm. You think about how every culture on Earth has looked up at this same spiral arm and given it names. The Greeks called it a river of milk. The Chinese saw a celestial river. The Navajo, a path of spirits. It's remarkable that a structure so enormous, so physically real, can also be a source of human meaning. The arms of the galaxy stretch across both space and imagination. They connect the cosmic and the personal, reminding you that wonder is a form of gravity too. It keeps you close to what you don't yet understand. The spiral around you glows brighter as your awareness drifts outward. The arms fade into the distance, curving toward the unseen center where everything turns together. The Milky Way is still growing, still reshaping itself, still balancing on the edge between order and change. And as you follow the soft spiral of light, you begin to feel that same pattern inside yourself, a gentle, endless motion, circling quietly toward peace. You float deeper into the spiral's quiet folds, where the light thins and the space between stars grows wide. Here, most suns move gently in step with the galaxy's rotation. Their orbits are smooth, predictable, each following its own path, like dancers gliding across a silent floor. But not all stars obey the rhythm. Some have been flung outward, hurled into the dark at unimaginable speeds. These are the rogues, the wanderers, the restless ones that refuse to stay. Astronomers call them hypervelocity stars, and they are among the strangest travelers in the Milky Way. Imagine one now, racing away from the core. It burns bright and lonely, moving faster than 1,000,000 kilometers an hour. That's quick enough to leave the galaxy entirely, to break free from the Milky Way's gravity and drift forever through intergalactic space. You picture it as a pale spark, streaking into the dark like a comet with no tail, no home, no return. Somewhere behind it, the galaxy grows smaller, its spiral arms folding back into distance. This star is exiled, but it shines all the same. The cause of such extraordinary speed lies near the galactic heart, where gravity grows fierce. Deep in the Milky Way's center, the supermassive black hole waits a quiet predator surrounded by swirling stars. Many of those stars exist in pairs, orbiting each other in delicate balance. When such a pair drifts too close to the black hole, the result is violent grace. One star is captured, drawn inward to vanish beyond the event horizon. The other is slingshotted outward with immense force, flung away like a stone released from a cosmic sling. Its partner is gone, but it carries the memory of that encounter forever, motion without end. Scientists still wonder how often this happens. We've found only a few dozen hypervelocity stars so far, but computer models suggest there could be millions, faint and scattered, speeding silently through the outer halo. Some may have been ejected billions of years ago, now crossing the cold emptiness between galaxies. Others may have come from distant systems, sent hurtling our way by the same invisible mechanics. The Milky Way, for all its order, has moments of wild release, flashes of chaos, in an otherwise measured rhythm. You imagine riding alongside one of these runaway stars. The galaxy recedes behind you until it's just a hazy disk of light. The black void ahead feels infinite, but not empty. Faint threads of gas stretch across space, and distant galaxies gleam like islands on a calm sea. The star's light grows faint as it burns through its fuel, but its momentum never fades. It will travel for billions of years, long after its own glow has dimmed, carrying fragments of the Milky Way's story into the deep dark. Each rogue star is a messenger, a piece of the galaxy cast adrift. By studying their paths, astronomers can learn about the Milky Way's mass and the nature of its central black hole. The faster a star escapes, the stronger the gravity it fled. These stellar exiles, though solitary, help us understand the shape of the home they left behind. They are like sparks showing the outline of a fire unseen. Sometimes the violence that creates these stars doesn't come from black holes at all, but from their own kind. When a binary star system experiences a supernova, when one companion explodes in a final act of brightness, the other may be flung away by the blast. These explosions act like cosmic catapults, propelling their survivors into the galactic void. Somewhere out there, countless solitary suns are traveling through the dark, unaware of how they were made to wander. Their stories are brief and brilliant, marked by loss and motion. You think about what it means to escape a galaxy. Gravity, the quiet ruler of the cosmos, is patient and strong. To break its pull requires immense speed, but even more, it requires the perfect direction, an alignment so precise that almost nothing achieves it. The odds are tiny, and yet, some stars do it. They find the exact path through the gravitational labyrinth that leads to freedom. In a universe where everything orbits something else, their solitude is both extraordinary and lonely. Scientists still debate what happens to such travelers after they leave the Milky Way. Do they wander endlessly until the universe cools into silence? Could they ever find another galaxy's pull and become part of a new system? The answer isn't clear, and maybe that's part of the beauty. Every rogue star is a question left unanswered, a flicker of mystery against eternity. Closer to home, not all rogue stars escape completely. Some travel so far that they hover at the edge of the halo, slowed by the galaxy's pull but not entirely caught. They drift there for ages, looping in long, graceful arcs before slowly returning inward. These partial exiles trace the outer boundaries of the Milky Way, defining its reach in a way no map could. The galaxy doesn't end in a clean line. It fades, like breath on glass. You picture that halo now, a vast sphere surrounding the bright disk, filled with ancient clusters and lonely wanderers. The rogue stars move through it like comets of pure fire, their paths unpredictable. Some will eventually cool into white dwarfs, small as Earth but heavy as suns. Others will explode before they ever escape, leaving only faint remnants of radiation behind. Each one is a reminder that even within gravity's empire, rebellion is possible. Down in the galactic disk, where stars follow orderly paths, you begin to appreciate their calm. The sun's steady orbit feels different now, secure, balanced, measured. Our solar system may never travel far beyond its lane, but perhaps that stability is what allows life to exist here at all. Not every journey needs to break free. Some are meant to linger, to revolve, to stay. Still, the image of those runaway stars lingers in your mind, their brilliance, their silence, their unending flight. The Milky Way may bind most of its stars in gravity's embrace, but it also makes room for a few to wander. There's something poetic in that balance. A galaxy large enough to hold both loyalty and freedom, both order and release. As you drift back toward the spiral's steady arms, you can almost see one of those exiles fading into the distance, a single moving spark, vanishing into endless dark. And as it disappears, you realize it's not escaping at all. It's expanding the galaxy's story, carrying a piece of it into the infinite beyond. The light begins to shift as you drift farther into the galactic distance. Stars grow denser, then sparser again, as if you're passing through cosmic tides, bright waves, and dark troughs of starlight. Far ahead, a faint haze gleams like a neighboring lantern across a vast lake. It's the Andromeda Galaxy, our closest large companion, spiraling silently through the dark. It looks small from here, but it's immense. Another island of hundreds of billions of stars, moving steadily toward us across the cosmic void. Andromeda isn't just any neighbor, it's our future. You are watching the slowest and grandest dance imaginable, a waltz of galaxies that began billions of years ago and will end billions of years from now. The Milky Way and Andromeda are on a collision course, drawn together by their mutual gravity. Every night you look up at the stars. You're watching this approach in progress, though it moves too slowly for any human lifetime to notice. Still, the outcome is certain. The galaxies are destined to meet. Imagine it. Two enormous spirals, each over 100,000 light-years across, drifting toward one another in utter silence. They are separated now by about 2.5 million light-years, an emptiness so vast that light itself takes that long to cross it. Yet their fates are entwined. With every passing second, they move closer by 100 kilometers. It seems small, but over billions of years, that speed will close the gap. Roughly 4.5 billion years from now, they will begin to touch. Scientists have modeled this cosmic encounter with careful precision. When the two galaxies finally meet, their stars will not crash together. The distances between stars are simply too immense. Instead, they'll weave through each other, like waves passing through waves. Gravity will stretch their arms into long, luminous streamers, tails of stars cast outward into the dark. Entire solar systems will be displaced, flung to new orbits, some closer to the center, others pushed to the edges or beyond. The galaxies will tear at one another's structure, reshaping both into something new. You can almost see it in your mind's eye. The Milky Way's graceful spiral arms distort, curling outward like ribbons caught in wind. Andromeda's bright core flares as gas clouds compress and ignite, birthing a sudden storm of new stars. The night sky from Earth, if Earth still exists, then will be transformed. Instead of a single faint band of light, the heavens will blaze with the outline of another galaxy filling the view. Each night, its glow will grow brighter, larger, until it dominates everything, a cosmic sunrise that never ends. It sounds catastrophic, yet there's a kind of calm inevitability to it. This is not destruction in the human sense, it's evolution. Galaxies live through cycles of merging, their collisions shaping the universe's history. The Milky Way itself was built this way, piece by piece, through countless unions with smaller systems. The meeting with Andromeda is simply the next chapter, the continuation of that long story. Scientists predict that after billions of years of interaction, the two will finally settle into a single, larger galaxy, probably an elliptical one, smooth and radiant, with no distinct arms left. Some have even given it a name, Milkomeda. You whisper the name to yourself and let it linger. It feels soft, almost human, like something alive. In that merged future, the sun will have aged into a red giant or faded into a white dwarf. The Earth may no longer exist, swallowed by the sun's expansion or frozen in darkness. But the remnants of the solar system, perhaps Jupiter, perhaps fragments of what was once our world, will orbit within this new galactic body, a survivor of both stellar and cosmic transformation. Scientists still wonder exactly what path this merger will take. The orbits of both galaxies are influenced by their halos of dark matter, massive, invisible envelopes that extend far beyond their visible edges. These halos will meet long before the stars do, their gravities tugging and twisting the galaxy's shapes. Simulations show different outcomes depending on those invisible details. Some predict a direct head-on collision. Others suggest a more graceful spiral, with each galaxy looping around the other several times before finally merging. The result, however, is always the same: two becoming one. You picture what that final form might look like: the smooth glow of a massive elliptical galaxy, its heart dense with old stars, its outer regions laced with faint, ghostly streams, the leftovers of the spirals that once were. Around it, smaller galaxies continue to orbit, drawn in over time, feeding its light. It will be quieter then, less active, a great glowing ember, slowly cooling in the universe's expanding night. And yet, in that stillness, new stars may still form, born from the gas clouds compressed during the merger. Even endings, in the cosmos, are never final. If you could somehow witness the collision from a safe distance, it would unfold slowly, beautifully. Over millions of years, the galaxies would pass through each other, then draw back, connected by bridges of starlight. They would collide again, each time more entwined. The process is so gradual that from one human lifetime to the next, the change would be imperceptible. You would look up at the same sky and think nothing had changed. Yet over eons, the transformation would be complete. The thought is humbling. Human history, the rise of civilizations, the span of languages, the creation of art and music, fits into a sliver of that timescale. And yet, here you are, part of a galaxy, on its way to meet another, your life a flicker in its grand journey. The inevitability of that meeting doesn't bring fear, it brings perspective. You are part of something vast enough to erase hurry, vast enough to cradle both beginning and end without judgment. You let your mind drift farther into that future. The galaxies merge, and for a moment, the universe is brighter, two rivers of stars blending into one. Perhaps some distant civilization, orbiting another sun, will look up and see the light of Milkomeda, unaware of the worlds that came before. The Milky Way's story will live on, not as a separate thing, but as part of something greater, woven into a single, seamless glow. As the vision fades, you return to now. Andromeda is still far away, still a faint smear of light in the constellation that bears its name, but its approach is constant, patient, unstoppable. The night around you feels a little softer, knowing that even the grandest collisions can lead to beauty. The universe isn't rushing toward chaos, it's spiraling toward transformation, one slow embrace at a time. You drift inward again, back toward the quieter edges of the Milky Way, where the halo of old stars circles the disk like a soft, invisible crown. The stars here move with strange precision, some spinning one way, others in reverse. From afar, they seem to form a delicate pattern, like threads of light weaving in opposite directions. You begin to notice that not every star follows the same flow. Some orbit backward, defying the general rotation of the galaxy. They are outliers, time travelers of a sort, moving against the current of everything around them. These backward-moving stars carry secrets of the Milky Way's history, secrets older than most of its light. Long ago, when smaller galaxies collided and merged into the young Milky Way, their stars were absorbed into its halo. Many of those stars kept their original orbits, their ancient momentum preserved. Even as the Milky Way spun forward, they continued in the direction they had always known. Their movement is a silent memory, a record of past collisions, written not in words, but in motion. Astronomers have traced some of these counter-rotating stars back to specific events. One major clue lies in a collection of stars known as the Gaia-Sausage-Enceladus merger. About 10 billion years ago, a smaller galaxy named Enceladus crashed into the early Milky Way. Its stars spread outward, forming elongated orbits that loop both with and against the galaxy's rotation. This colossal impact reshaped the Milky Way's very structure, thickening its disk, stirring its halo, and giving rise to the stars that still move in defiance today. You imagine watching that ancient collision unfold. The young Milky Way, still forming, is struck by another shining mass. Their dark matter halos merge first, dragging the stars together like merging clouds. Gas compresses and ignites, birthing new suns in bright waves across the sky. For millions of years, chaos reigns. Streams of stars torn from their homes, flung into strange orbits. And then, slowly, order returns. The debris settles, the stars calm, and a new, larger galaxy takes shape, richer, more complex, yet forever marked by what came before. Even now, that memory endures. Those ancient stars still travel their odd paths, looping through the halo, crossing the galactic plane like echoes of an earlier universe. Scientists still wonder how many such mergers the Milky Way has experienced. Every few years, new data from the Gaia spacecraft reveals another faint population of stars moving in strange ways, some faster, some slower, some backward. Each discovery adds another verse to the galaxy's long song of creation and collision. You drift alongside one of these backward travelers now. It shines faintly red, old and wise, orbiting high above the galactic disk. Around it, the Milky Way glows like a misty wheel turning below. The star's motion feels deliberate, its direction purposeful, though it has no will of its own. You realize that even chaos in the cosmos carries structure. Nothing is truly random. Every path has roots in history. The star's orbit is the echo of a moment 10 billion years gone, a fossil of motion, still circling through the dark. Sometimes, entire groups of such stars move together, forming streams that wrap around the galaxy like ribbons. These are the remnants of swallowed companions, dwarf galaxies pulled apart by gravity. Their stars spread along vast tidal trails. Astronomers have named some of these streams: the Sagittarius Stream, the Orphan Stream, the Helmi Stream. Each one marks the grave of a smaller galaxy, now woven into the Milky Way's body. The stars along these paths move in unison, tracing the invisible lines of their former homes. You picture these stellar streams stretching across the halo threads of memory, glowing faintly against the night. To the unaided eye, they are invisible, but to instruments that can track motion and chemistry, they are unmistakable. Each stream has its own distinct fingerprint, stars of similar age and metallicity, moving in harmony. It's as though the Milky Way keeps a diary of everything it has ever consumed, each entry recorded not in ink but in starlight. Scientists still debate how these mergers shaped the Milky Way's form. Did they create its thick disk? Did they set its spin? Some theories suggest that our galaxy's peculiar warp, a subtle bending of its plane, is the lingering effect of ancient collisions. Others believe the passing of dark matter, clumps through the disk, caused waves that ripple through the stars like sound through water. The galaxy, though vast, remembers its past, not in stillness, but in motion. Every oscillation, every irregular orbit, is part of that remembrance. You look down upon the galactic plane, luminous and thin, like a vast disk of light, slowly spinning through eternity. The majority of stars move together, their combined gravity maintaining balance. Yet scattered among them are the few that defy the flow, tiny countercurrents within the great river. You find comfort in their persistence. Even in the largest systems, individuality survives. Each star's path matters. Each motion adds depth to the whole. The backward-moving stars are quiet philosophers of the galaxy. They carry with them the truth that not all journeys follow the same direction, and yet every path remains part of the greater pattern. You imagine them gliding through the night, unseen by most, yet essential to the story of everything that is. Their orbits, though strange, maintain the harmony of the Milky Way structure, keeping its outer halo alive with gentle motion. Below, in the spiral arms, new stars are born bright, hot, impatient. They race forward with the galaxy's spin, unaware of the ancient travelers above them. But someday, long after they burn out, they too will become part of that memory. Their ashes will drift upward into the halo, joining the quiet motion of the elders, circling both with and against the flow. The cycle continues. New life, old motion, enduring light. As you drift further into the dark, the backward stars shimmer like sparks in reverse, moving toward the dawn instead of away. They remind you that time, on a galactic scale, isn't linear. Every orbit is a loop, every history a circle. Nothing truly ends. It just turns again. The galaxy, in its vast wisdom, knows this truth. It turns forward and backward at once, all motion woven into a single, silent harmony. You breathe out slowly. The air feels still, but the universe keeps moving, its currents winding endlessly. Somewhere far above, one lone star continues its backward glide, tracing an ancient arc through space. You watch it until it fades, knowing it's not lost, it's simply remembering the way home. You drift even higher above the glowing spiral, to where the light begins to thin into transparency. The stars here are faint and far apart, their orbits stretched like silk threads around the Milky Way's heart. From this height, the galaxy looks almost still, a shimmering whirlpool of light, encased in a soft halo of dust and starlight. But there's a deeper story written into this calm shimmer. Every grain of that halo, every arc of faint light, once belonged to something else. The Milky Way, for all its grace, is a collection of consumed worlds. Long before it became the spiral you recognize today, the Milky Way was a gathering place for wanderers. Tiny galaxies drifted toward it, drawn by its growing mass. When they came too close, its gravity tore them apart. Their stars stretched into long, luminous streams. The galaxy devoured them gently, folding their remnants into its own body. Each of those lost companions left behind faint signatures, ghostly arcs of motion, unusual clusters of stars, chemical fingerprints that betray their foreign birth. The Milky Way is not a single creation. It's a mosaic of collisions, a patchwork made of cosmic inheritance. Scientists have identified many of these devoured galaxies by tracing the motion of stars. The Sagittarius dwarf galaxy, for example, is still being eaten right now. It orbits the Milky Way's center in a decaying loop, each pass shedding more of its stars into great streams that wrap around the disk. One day, its core will dissolve entirely, leaving only trails of its light woven into the halo. To the human eye, those stars will look like any other. But their chemistry tells another story, a tale of a world that once was whole, now blended into something greater. You can almost picture the process. A small, faint galaxy drifts close to the Milky Way's outer rim. Its shape distorts as gravity tugs unevenly across it. Stars on the near side accelerate toward the Milky Way, while those farther away lag behind. The smaller galaxy stretches, like pulled taffy, until it unravels. Its stars no longer orbit one another, but begin to circle the Milky Way instead, their original order replaced by the larger galaxy's gravity. Over millions of years, what was once a separate world becomes part of the halo, indistinguishable except to those who know where to look. The discovery of these remnants came from careful mapping, made possible by satellites like Gaia. By measuring tiny differences in motion fractions of a degree over years, astronomers can see patterns invisible to the naked eye. They've found dozens of streams wrapping the sky, each one a relic of a galaxy the Milky Way consumed. The names read like poetry: the Helmi Stream, the Phoenix Stream, the Cetus Polar Stream. Some are broad and bright, others are faint as whispers. Together, they tell a story of hunger and renewal, a galaxy that grows by gathering. Scientists still wonder how many such mergers have shaped the Milky Way's past. Some models suggest as many as 100 dwarf galaxies have been absorbed over time. Others think there may have been far fewer, but larger events, colossal collisions that permanently altered the galaxy's shape. Either way, the result is clear. The Milky Way's smooth beauty is born from turmoil. Its light is both creation and consequence, peace built upon the memory of chaos. You imagine the galaxy's early years, when it was young and wild. The universe was denser then, and galaxies lay closer together. Collisions were frequent, and the Milky Way grew rapidly, swallowing neighbors to strengthen its spiral. Each merger added new stars, new gas, new dark matter, but it also brought disruption, gravitational waves that rippled through the disk, shaking its structure like a struck bell. The echoes of those impacts still travel through the stars today, gentle oscillations that astronomers can measure, faint but persistent. In this way, the Milky Way carries its ancestry within its own body. Its halo, diffuse and faint, is the collective memory of all that came before. Each faint star out there was once part of a smaller galaxy, long since devoured. If you could trace every orbit backward, you would see them converge, small clusters drawn together, colliding, merging, until they vanish into the Milky Way's glow. The halo is not empty space. It's a museum of cosmic history. You float among these relics now, and the view is breathtaking. Faint arcs of light stretch around you like ribbons, curving through the dark. Some are narrow and sharp, the remnants of recent mergers. Others are broad and diffuse, blurred by time. In the distance, globular clusters hang like lanterns, dense spheres of ancient stars, perhaps once the cores of swallowed galaxies that survived the feast. They glitter softly, holding their shape even as the larger structure around them evolves. They are survivors within the survivor. Closer to the galactic plane, you see dust clouds marking the next generation of stars. It strikes you that destruction and creation are never far apart here. The same gravity that tears galaxies apart also compresses gas into new suns. Every loss becomes fuel for rebirth. The Milky Way consumes, but it also gives back. Like a forest, it grows from its own fallen matter. Scientists still debate the future of this process. Will the Milky Way continue to devour smaller galaxies until there are none left nearby? Or will the gravitational tides of Andromeda's approach pull everything into a new phase of growth? Observations show that a few dwarf galaxies like the Magellanic Clouds are currently spiraling inward, their gas streams already feeding our own. Even now, the cycle continues. The galaxy has not finished its meal. You imagine standing on a planet, orbiting a star that once belonged to one of those lost galaxies. The sky there would look the same, stars above, blackness beyond, but its atoms, its very elements, were forged elsewhere. Its sunlight is a mixture of histories, a quiet collaboration between worlds that once were separate. You, too, are part of that inheritance. The atoms in your body may come from more than one ancestral galaxy. You are, in the deepest sense, made of mergers. The stars shimmer around you like embers floating upward, and you realize that the Milky Way's beauty is not the beauty of perfection, but of endurance. It's the result of billions of years of transformation, of collisions that became harmony. Every particle of light, every orbit, every quiet star is part of that vast, ongoing conversation between chaos and order. You take a slow breath, feeling the stillness between heartbeats. The galaxy continues to turn, as it always has. Around you are the ghosts of 100 smaller worlds, their light now part of the same glow that arches across your night sky. They are gone, but not lost, woven forever into the body of something larger, brighter, and alive. You glide along the faint curve of a stellar stream, the remnants of one of those long-ago mergers, and drift gently back toward the Milky Way's luminous disk. The light grows stronger again, thickening into bands of gold and silver. Here, among billions of stars, the air, or what would be air, if you could breathe it, feels rich with meaning. Every gleam around you is a chronicle, a record of age and ancestry. You begin to notice that not all stars shine alike. Some burn white and pure, others glow softly red or yellow. The difference is not only beauty, it's history written in color. Every star carries a fingerprint, hidden in its light. When astronomers split that light through a prism, they see a rainbow streaked with dark lines, like threads running across silk. Those lines are the marks of the elements the star contains: hydrogen, helium, iron, calcium, carbon, oxygen. The pattern of those lines reveals the star's metallicity, its level of heavy elements, and in turn, its age. The fewer heavy elements, the older the star. Each spectral line is a clue, a whisper from the past. You picture it now, a beam of starlight stretched through glass, scattering into color. A faint notch appears where iron absorbs a sliver of light, another where calcium hides it. Each one tells part of the story of how that star was born, what kind of gas cloud created it, what earlier generations of stars exploded to seed its ingredients. It's like reading tree rings, but on a cosmic scale. The Milky Way's history is written not in fossils or ruins, but in light itself. Scientists call this field galactic archaeology. It's an elegant term for something that feels almost spiritual, the study of how the galaxy built itself, one atom at a time. By comparing the chemistry of thousands of stars, astronomers can reconstruct the timeline of creation. Some stars, rich in metals, were born recently from material recycled through countless generations of stellar death. Others, metal poor and pure, are survivors from the galaxy's dawn. Together, they form a living record of time's passage, an autobiography of the Milky Way, written across billions of suns. You drift past one of these ancient lights. Its glow is soft and steady, its surface cool. When its spectrum is measured, it shows almost no trace of heavy elements. That means it was born before the Milky Way had grown rich, when the universe still held only hydrogen and helium. It's a star older than iron, older than carbon, older than the matter in your own body. In its light lies the echo of the first explosions that forged the heavier elements you now depend on. Nearby, a younger star blazes blue-white. Its light, when broken into its spectrum, tells a different story. Abundant oxygen, magnesium, silicon elements, forged by earlier generations of massive stars. The contrast between the two is like seeing history unfold side by side. One speaks of a sparse, newborn universe, the other of a galaxy already seasoned by time, bursting with complexity. They share space, but not the same ancestry. The Milky Way contains both the ancient and the newly made, turning together like pages of a single book. Scientists still wonder whether every element in the galaxy can be traced this way, back to its first source. Some, like iron and nickel, are known to come from the violent deaths of massive stars. Others, like gold and platinum, may form in the collisions of neutron stars, rare, catastrophic events that send ripples of gravity through space. Each discovery adds a new chapter to the story of how the Milky Way's chemistry evolved. Every atom tells a tale. You imagine the galaxy as a vast laboratory, one that's been running for 13 billion years. Stars are its experiments, supernovae, its tests, planets, its unexpected outcomes. Out of these reactions come the building blocks of life, the oxygen in your lungs, the calcium in your bones, the carbon in your skin. All of it was once trapped inside a star. When that star died, it scattered those elements into space, and over time, they gathered again to form you. In that sense, chemistry is memory. The galaxy remembers through its atoms. You pass through a dense cluster now, where the starlight thickens into gold dust. Some of the stars here move together, bound since birth. They formed from the same gas cloud, their chemical fingerprints nearly identical. Astronomers can identify such siblings even when they've long drifted apart. It's how they trace the family trees of stars, clusters that have dispersed across the galaxy, yet still share the same elemental DNA. The Milky Way is full of such families, scattered but connected, their shared chemistry an invisible thread tying them together. There's something comforting about this idea that even when stars wander far from where they began, they never truly lose their identity. Their light carries their origin forever. In that way, they're like people changing, moving, but always marked by the place and time they came from. The galaxy is not a random collection of stars. It's a vast, interconnected lineage, every light a descendant of what came before. Scientists still debate the finer details of this chemical evolution. How quickly did the first heavy elements form? How evenly were they spread across the galaxy? Did supernovae enrich the entire Milky Way evenly, or did pockets of gas remain pristine for eons? The answers lie in the data, in the subtle patterns of starlight. Each new survey adds precision to the map, revealing gradients of metallicity that sweep across the spiral arms. The inner regions are rich and heavy, the outer edges, lighter and more ancient. The Milky Way's chemistry, like a heartbeat, changes from center to rim. You drift farther outward, feeling those gradients blend around you. The colors of the stars begin to shift, redder and gentler, older and calmer. It's as though you're moving through time itself, from the vibrant youth of the inner galaxy to the quiet age of its outskirts. Everywhere you look, light becomes language. You realize that what astronomers read through telescopes is not just brightness, it's biography. Each wavelength carries history, each photon a message from long ago. And somewhere in that spectrum, faint but constant, lies the trace of everything you are. When you look at the Milky Way, you're seeing not just a galaxy, but your own reflection in cosmic form, made of the same materials, born of the same processes, bound by the same gravity. The elements in your body and the stars in your sky are kin. The universe has always been talking to itself through you. You let the thought linger, like the last line of a poem. Light, chemistry, time, they all flow into one another, forming the quiet truth at the center of everything. Nothing in the universe is separate. Every atom tells the same story, in a different voice, glowing softly in the dark. You drift along the outer rim of the spiral arm, following a faint, glimmering trail that winds like a ghostly river across the stars. It flows gracefully, pale and unbroken, wrapping around the Milky Way like a silken thread. These are the stellar streams, remnants of long-forgotten galaxies and clusters, stretched thin by time and gravity. They move quietly through the dark, carrying the memory of what once was, glowing faintly as they orbit through the galactic halo. From a distance, each stream looks like a faint scar across the sky. But when you move closer, you can see the truth. Thousands, sometimes millions, of stars, bound together by shared motion. Their paths are precise, their rhythm hypnotic. They are the veins of the galaxy, delicate traces of every meal the Milky Way has ever consumed. Where galaxies collide and merge, these rivers of light are born. You picture one such stream, the Sagittarius stream, perhaps the most famous. It wraps almost completely around the Milky Way, looping over and under the galactic plane. Its stars once belonged to the Sagittarius dwarf galaxy, now being slowly torn apart. Every orbit, more of its material is stripped away and added to the Milky Way's halo. From Earth, the stream appears as a vast arc across the sky, invisible to human eyes, but captured clearly by deep sky surveys. It's a reminder that galaxies do not simply exist, they flow, evolve, devour, and remember. Scientists still wonder how many such streams thread through the Milky Way. Some can be traced to known origins, others seem to appear from nowhere, their progenitors long since vanished. The Gaia Space Telescope, with its exquisite ability to track motion, has revealed dozens of these trails, faint but distinct. Each moves in its own way, some looping high above the disk, others slicing through it, like quiet echoes of ancient chaos. You imagine drifting along one, letting the stream carry you across the halo. The stars around you shimmer gently, far enough apart that each one feels solitary, yet all moving in unison, their velocities almost identical. Together, they form a celestial choreography that repeats endlessly. You are floating in a river of memory, carried by the gravity of the Milky Way itself. The origin of these streams lies in tidal disruption, a delicate phrase for something immense. When a smaller galaxy or cluster wanders too close to a larger one, its stars feel uneven pulls of gravity. Those closer to the Milky Way accelerate, those farther away lag behind. Over time, the difference tears the smaller system apart, stretching it into a stream that follows the same orbit as its former core. It's a slow, silent disassembly, unfolding over hundreds of millions of years. There's something both tragic and serene about it. The original galaxy ceases to exist, but its light continues, distributed across a path so vast it can encircle the Milky Way itself. The stream becomes a monument long, fragile, yet enduring. The stars within it will keep moving together for billions of years before they finally dissolve into the general sea of the halo. Scientists still debate how much of the halo's light comes from such streams. Some believe that nearly all of it is the result of past mergers, the faint debris of galaxies long gone. Others suggest that some parts formed in place, as isolated stars or clusters. The truth may be both an intricate blend of capture and creation, like threads woven from many origins into one shimmering tapestry. You pass through another, thinner stream now, one whose stars are older, redder, dimmer. Their light pulses faintly, like the last coals of a cooling fire. These may be the remnants of a globular cluster, tight groups of ancient stars that once orbited together. Over time, even such dense formations can be stretched apart by gravity's pull. As they unravel, they leave behind trails narrower than a single degree across the sky, delicate and precise. One such stream, named GD1, was discovered only recently. It stretches across more than 100 degrees of the heavens, slender as a thread. Astronomers found it by tracing the motions of stars that move together against the background, all sharing a single trajectory. By following those motions backward, they could reconstruct the original cluster that created it, though that cluster itself may already be gone. The stream outlives its source. It becomes its own story. You begin to realize how much of the Milky Way is built on this quiet persistence. Stars die, galaxies collide, clusters dissolve, but nothing is truly lost. Everything leaves traces: chemical, gravitational, luminous. The galaxy keeps them all, folding them into its shape. Even when the stream fades beyond detection, its stars remain bound, their motions still whispering their shared past to anyone who can listen. You drift closer to the galactic plane now, and you can sense faint ripples of motion passing through the disk waves caused by older mergers, still propagating after billions of years. The galaxy is a pond in which every stone ever thrown leaves a mark long after the splash has faded. Each stellar stream is one of those ripples, frozen in motion, yet always changing. Scientists still wonder whether new streams are forming even now, as small dwarf galaxies continue to approach. Some point to the Magellanic Clouds, two bright, irregular companions visible from the southern hemisphere, as active examples. They are already connected to the Milky Way by filaments of gas and stars, precursors to future streams. In time, they too will be stretched and absorbed, their stars joining the halo's vast, invisible circulation. The image of it fills you with quiet awe. The Milky Way is not a fixed shape, but a living flow, every stream a pulse of its larger heartbeat. You think of rivers on Earth, how they carve valleys, how they join and separate, how their waters never truly disappear. The galaxy behaves the same, though on scales too large to imagine. Its stars flow through it like eternal currents, never ceasing, never still. As you glide through the last of the faint light, the streams around you begin to dissolve into the greater glow of the halo. They fade gently, like dreams slipping from memory, yet their paths remain imprinted in space. The galaxy remembers everything. It remembers every collision, every drift, every bright birth and quiet end. The stars may change, but the story continues fluid, endless, luminous. You move closer to the heart of the Milky Way once more, sinking gently toward its disk. From a distance, the spiral looks perfectly flat, a polished whirl of stars and dust. But as you draw nearer, that illusion fades. The galactic plane bends and twists, rising at the edges like a ribbon caught in a slow breeze. The Milky Way is not a perfect disk at all. It's subtly warped, its structure rippled and curved, as if space itself once trembled and never quite settled again. From your vantage point, it's mesmerizing. The edges of the disk lift upward on one side and downward on the other, a soft asymmetry spreading across hundreds of thousands of light years. You drift above it, and the galaxy looks like a cosmic wave frozen mid-crest, a luminous sheet of starlight folding against the night. The cause of this grand curvature is still uncertain. Scientists still wonder whether the warp comes from within or without. Perhaps the Milky Way's dark matter halo, the invisible mass surrounding it, isn't evenly shaped, pulling the stars unevenly like a hand twisting a plate. Or perhaps the warp was caused by past encounters, the gravitational aftershocks of smaller galaxies passing nearby. One leading theory points to the large Magellanic Cloud, a bright dwarf companion currently orbiting our galaxy. Its immense gravity may be tugging on the Milky Way's outer edges, creating the slow, elegant bend you now see. You imagine the moment it began hundreds of millions of years ago, when the Milky Way's outer rim first tilted slightly out of plane. That small distortion, amplified over time, became the vast arc you see now. The galaxy flexed like a living thing, its stars adjusting to new gravitational patterns. Even now, the warp continues to move, not static, but dynamic, a slow ripple traveling through the galactic disk. The stars themselves are part of the wave, oscillating up and down as they orbit, a billion-year-long rhythm that never stops. From above, you can see the effect clearly. The bright band of the galactic mid-plane snakes gently through the void, its edges glowing faintly where they curve toward you. Dust lanes trace its shape, dark filigree against the starry light. The overall effect is strangely familiar, like the surface of a calm sea seen in moonlight, shimmering, undulating, alive. As you move through the warp, you realize how vast it is. The Milky Way's diameter stretches over 100,000 light-years, and yet this curvature, though subtle, spans it all. The difference in height between one edge and the other is nearly 3,000 light-years, tiny compared to the whole, yet immense beyond comprehension. If you could somehow stand on one edge of the galaxy and look across, the other would be slightly above or below you, just enough to make the entire structure feel alive. The warp doesn't exist only in the stars. The gas that fills the Milky Way, especially hydrogen, follows the same curve. Radio telescopes, tuned to the specific frequency of neutral hydrogen, have mapped the entire structure, revealing its graceful bend. These maps show that the warp isn't random. It follows a pattern, symmetrical and smooth, as if the galaxy were being twisted by a steady, gentle hand. Scientists still debate whether the warp is temporary or permanent. Some models suggest it will eventually flatten as the Milky Way's internal forces, its rotation and gravity, settle into equilibrium. Others propose it will continue to oscillate forever, its motion fed by the constant pull of the Magellanic Clouds or other unseen satellites. The galaxy, they argue, is never entirely still. Like a flag in the cosmic wind, it ripples in response to every nearby mass. You pass through the region where the warp begins, and you can feel the difference, not as force or vibration, but as a subtle change in the density of starlight. The stars seem tilted, their orbits slanted slightly against the galactic plane. The motion is slow, but steady. It's almost soothing, like watching a great pendulum swing in silence. Closer to the core, the warp fades, and the galaxy flattens again. Here, gravity's pull is stronger, the stars more tightly bound. The Milky Way's inner disk remains remarkably stable, anchored by the dense bulge and central bar. But beyond the calm center, chaos gently returns, rising and falling like breath. The transition from order to motion, from flatness to curve, feels natural, as if the galaxy itself were exhaling across its edges. You think about how every large galaxy likely bears such imperfections. The elegant spirals you see in photographs, flat, symmetrical, flawless, are simplifications, brief moments in a longer story. In reality, each one is warped, lopsided, swaying ever so slightly in response to unseen forces. There's comfort in that imperfection. Even on a cosmic scale, balance is a dance, not a fixed point. As you drift along the outer rim, you see faint signatures of other disturbances, ripples within the warp, smaller waves caused by ancient collisions. They move through the stars like echoes through water, each one a trace of something that once passed by. Some astronomers call them galactoseismic waves, the Milky Way's equivalent of aftershocks. They remind you that the galaxy is not merely light, it's soundless motion, responding to every touch. The warp, though invisible to most eyes, reveals itself in subtle ways. When you gaze at the Milky Way from Earth, its central band appears slightly tilted, a gentle rise toward one horizon, a dip toward the other. You might not notice it, not consciously, but it's there, the faintest hint of that cosmic curve written across the sky. You live within that bend, carried along by it, part of the wave that moves through time and space. You breathe in deeply, as though mirroring the galaxy's rhythm. It's humbling to think that even the Milky Way, so massive, so ancient, is still in motion, still shaped by what surrounds it. Every galaxy in the universe influences every other, their gravities entangled in an endless web. The warp you float through is not a flaw but a reminder. The cosmos is alive, connected, responsive. Below you, the spiral arms shimmer in slow rotation, rising and falling like the tides of eternity. You drift above them, feeling the shape of the galaxy not as something solid, but as something breathing a ripple of starlight that never quite rests. The Milky Way doesn't need to be perfect to be beautiful. Its grace lies in the way it bends. You drift farther outward again, where the spiral arms grow thin and the starlight begins to fade into emptiness. The Milky Way stretches across your vision like a glowing river, soft, silver, and infinite. It feels so immense that it's hard to imagine it having limits at all. Yet, as you float within it, you begin to realize that what you see, even at its most breathtaking, is only a droplet of its true light. From Earth, on a clear, moonless night, the Milky Way looks like a hazy band stretching across the sky. But that gentle glow is deceiving. It comes from only a tiny portion of the galaxy, the brightest nearby stars in the disk, scattered across a narrow window of the sky. Most of the Milky Way remains invisible, hidden behind thick curtains of dust and distance. You live inside it, surrounded by hundreds of billions of stars, yet you can see only a few thousand with your eyes. The rest is cloaked in silence. You imagine standing beneath that night sky again, feeling the cool air, watching that faint, misty arc overhead. Every pinpoint of light is its own world, its own sun, with its own stories, its own orbit through the galactic sea. Yet, compared to the whole, what you see is like looking at a single grain of sand and calling it a desert. The galaxy is too vast to behold all at once. Even light, swift as it is, takes 100,000 years to cross from one side to the other. Scientists have tried to map this unseen expanse, using every form of light the universe offers. Optical telescopes reveal the luminous stars near the galactic core. Infrared observatories peer through dust to uncover the cooler, hidden regions. Radio telescopes trace the faint whispers of hydrogen gas that fill the spiral arms. X-ray instruments capture the violent glow of supernovae and black holes. Each wavelength adds another layer to the picture, a composite portrait built piece by piece, like feeling the shape of a mountain by tracing its shadow. And yet, even with all these tools, the Milky Way remains partly unknown. Clouds of interstellar dust obscure much of its structure. The galaxy's far side is hidden behind its own light, a veil of brightness that even the most powerful telescopes struggle to penetrate. Scientists still wonder whether there are spiral arms, clusters, or even entire features we've yet to see. It's humbling, this idea that you live inside one of the most studied galaxies in the universe and still cannot see it whole. You drift through the dark lanes that block our view, ribbons of dust, cold and dense, winding through the starlit disk. They absorb visible light, making the night sky appear mottled and streaked. These clouds are not empty though. They are the birthplaces of new stars, vast wombs of gas where gravity quietly gathers matter. The same shadows that hide the galaxy from sight are also the nurseries that keep it alive. Darkness and creation coexist here, inseparable. As you float through one of these clouds, the starlight dims to a faint amber glow. Grains of carbon and silicate dust drift like fine smoke around you. They're smaller than sand, yet together, they block entire constellations from view. You reach out as though to touch one, knowing it's the same kind of dust that formed the planets, the same dust that one day became life itself. What hides the galaxy also makes it possible. Beyond the cloud, the light returns soft, diffuse, endless. You can see the curve of the galactic plane stretching ahead, a pale horizon of stars. The sheer number is dizzying. Even now, astronomers estimate that the Milky Way holds at least 200 billion stars, perhaps many more. And yet, most are invisible to the eye. Some are too faint, others too distant, others buried in dust. To you, the night sky is a tapestry of bright points. To the galaxy, it is a sea of fire, unbroken and vast. Scientists still debate how much of the Milky Way's true light we can ever capture. Some say less than 1% of its stars are visible from Earth without aid. Others calculate that even our most advanced telescopes miss entire populations, cold dwarfs, dim giants, and hidden clusters. The universe is generous, but it's also elusive. It shows you enough to inspire wonder, but never enough to end it. You drift now toward the galactic center, where the light grows thicker, the stars more crowded. For every patch of darkness, there are 1,000 suns beyond it. It's hard to separate one from another. They blend into a golden haze, a living fabric of energy. The Milky Way glows brightest here, but it also conceals the most. The density of stars makes distance meaningless. Light overlaps light until the view becomes a blur. It's like trying to see the forest when every tree burns with its own fire. You pause to take in the sight, the hidden brightness of a galaxy that cannot be fully seen. There's something deeply peaceful about it. The limits of sight are not failures, they are boundaries that keep mystery alive. You realize that even if you could see the Milky Way in full, every arm, every cluster, every wisp of gas, the wonder would not end, because behind that, there would still be more. The galaxies beyond, the cosmic web, the unknown stretching forever outward. The thought makes you smile. Humanity, for all its telescopes and equations, still walks through the cosmos with lanterns, small pools of light surrounded by infinite shadow. And yet, that lantern's glow is enough to reveal beauty beyond measure. The Milky Way doesn't need to show itself completely to be magnificent. It offers glimpses, whispers, moments just enough to remind you that you're part of something far greater than comprehension. You drift slowly back toward the edge of the spiral, where the stars thin again and the darkness deepens. The faint haze of the Milky Way lingers in the distance like a memory. You can't see all of it, but you can feel it, surrounding you like a heartbeat you'll never quite hear but always sense. The galaxy doesn't need to reveal its full shape. Its mystery is its light. You float on the outskirts of the glowing spiral, where the air of light thins into velvet darkness. The stars here grow sparse and delicate, each one a solitary flame. The Milky Way feels different from this distance, quieter, slower, almost contemplative. It's here, in this stillness, that you begin to sense something unseen yet immense, a weight that doesn't shine, a presence that binds everything together. This is the invisible framework of the galaxy, the dark matter that holds it in place. You can't see it, but you can feel its influence everywhere. The way the stars move betrays it. The galaxy spins too fast for the visible matter alone to hold it together. If only the stars, gas, and dust were providing the gravity, the outer edges would fly apart, flinging suns into the dark. And yet they don't. The spiral arms remain steady, the halo intact. Something unseen must be adding mass, an unseen hand that keeps the Milky Way whole. Scientists have spent decades searching for this missing matter. They've named it dark matter not because it's dark in color, but because it doesn't interact with light at all. It doesn't glow, doesn't absorb, doesn't reflect. It's invisible in every wavelength we know. And yet, it outweighs everything you can see, 5 times more abundant than all the luminous matter in the universe combined. The stars you see are only the frosting. Dark matter is the cake beneath. You drift now through that invisible ocean, feeling its presence like pressure without touch. It surrounds you, not as a mist or fluid, but as a gravitational field, soft, pervasive, absolute. It stretches far beyond the visible disk, forming a halo that extends hundreds of thousands of light years in every direction. Without it, the Milky Way wouldn't exist as it does. The spiral arms would unravel, the orbits would fail, the galaxy itself would dissolve. Dark matter is the silent architect of everything that holds form. Scientists still wonder what dark matter truly is. Some think it's made of undiscovered particles, weakly interacting massive particles, or WIMPs that rarely collide with normal matter. Others suspect it could be something stranger, ultralight particles behaving like waves, or entire populations of black holes too small to detect. Every theory paints a different picture, but all agree on one truth: without dark matter, the universe as we know it couldn't exist. You imagine the Milky Way's dark halo now, an immense sphere stretching far beyond its luminous edge. Within that halo, the visible galaxy is a jewel suspended in an unseen crown. Stars orbit within it, unaware of the structure that guides them. Gas clouds drift through its embrace, their paths subtly curved by its pull. It's a cosmic paradox, something that shapes everything yet reveals nothing. Astronomers have found ways to measure it indirectly. They map the speeds of stars, the bending of light from distant galaxies, the clustering of cosmic structures. All these observations point to the same invisible presence. Even light itself cannot escape its influence. When it passes near a concentration of dark matter, it bends slightly, like water around a stone. This phenomenon, gravitational lensing, has become one of the most elegant proofs of dark matter's existence. The universe, in its silence, leaves fingerprints. You drift higher now, out of the galactic plane, until the Milky Way spreads below you like a glowing spiral surrounded by darkness. But that darkness isn't empty. It's filled with the gravitational haze of dark matter, unseen but essential. You can almost feel the balance between light and shadow, matter and mystery. It's as if the galaxy is wrapped in a cosmic cocoon, protected by the very thing that hides it. Scientists still debate whether dark matter behaves the same everywhere. In the dense centers of galaxies, it seems more concentrated, while in the outskirts, it thins into smooth gradients. Some simulations suggest it forms filaments, thread-like structures, connecting galaxies across the universe, the cosmic web itself, made of dark matter scaffolding. The visible galaxies are merely bright beads, strung along those invisible threads. Everything luminous rides upon the dark. The thought makes you feel small, but also deeply connected. The gravity that holds the Milky Way together also binds you to it. You are part of that same invisible web, every atom in your body following the same unseen laws. You are made of ordinary matter, but you live inside dark matter's embrace. The two coexist, silent partners in the great architecture of the cosmos. You imagine trying to touch it, to catch even a particle of this elusive substance. Scientists have built vast underground detectors, giant chambers shielded from cosmic rays, hoping to glimpse the faintest collision between dark matter and normal atoms. For decades, those detectors have waited patiently, listening for a whisper that hasn't yet come. Some say we're looking the wrong way, that dark matter may not be made of particles at all, but something more abstract, more geometric, a property of space itself. The answer remains hidden, like a secret too large for language. And yet, even without understanding it fully, we know how to live within it. The Milky Way's stars move in graceful order because of it. Planets orbit their suns because of it. You, sitting quietly under the night sky, are held in place by its gentle pull. The invisible and the visible coexist in harmony, neither overpowering the other. The galaxy is not just made of light, it's shaped by shadow. You breathe slowly, the stars around you soft and endless. The idea of dark matter no longer feels unsettling. It feels natural, even comforting. The universe, you realize, doesn't need to be fully seen to be known. Some truths are meant to be felt, not observed. Some mysteries are not walls, but frameworks, structures that hold everything together without ever asking to be found. You look one last time at the Milky Way's edge, glowing faintly against the invisible sea. It turns silently within its unseen halo, as it has for billions of years. The light is beautiful, but it's the dark that makes it possible. You drift inward once more, toward the center of the Milky Way, the quiet heart that anchors it all. The spiral arms curve inward, like rivers meeting at a basin, flowing toward a place of darkness and gravity. From afar, the core glows gold, dense, with stars packed so tightly that their light merges into a single, molten gleam. It looks serene, but beneath that glow lies something deeper, a weight so immense that not even light can escape. This is Sagittarius A*, the supermassive black hole at the center of our galaxy. You can't see it directly, but you can sense its presence. It sits just 26,000 light-years away from Earth, hidden behind clouds of gas and dust in the constellation Sagittarius. To the eye, that patch of sky looks unremarkable, a quiet cluster among millions. But through radio telescopes, its heartbeat hums softly bursts of energy that ripple through space. The black hole's mass is more than 4 million times that of the Sun, compressed into a region smaller than our solar system. It is both infinitely dense and perfectly silent. You draw closer, and the light grows fierce. Stars whip around the core at astonishing speeds, some circling in just a few years, racing at thousands of kilometers per second. They form a luminous whirlpool, their paths bent by invisible gravity. The closer you move, the more distorted everything becomes. Space itself begins to curve, time slows, and the line between motion and stillness blurs. The galaxy's calm facade hides a storm at its heart. Scientists have studied these orbiting stars for decades, tracking their motion with exquisite precision. One of them, named S2, has become a celestial clock. It completes its orbit around Sagittarius A times every 16 years, tracing a long, narrow ellipse that brings it perilously close to the black hole. When it reaches that point, it moves at nearly 3% of the speed of light. The data from S2's motion confirmed Einstein's predictions about gravity bending both space and time. The galaxy's center, invisible though it is, has become one of the best laboratories for understanding the fabric of reality. You imagine what lies beyond the black hole's edge, the event horizon, the point of no return. Here, gravity becomes absolute. Even photons, traveling at light speed, curve inward and vanish. No signal, no matter how strong, escapes. What happens inside remains forever hidden, a mystery wrapped within physics itself. Scientists still wonder what lies beyond that veil. Is it a singularity, a point of infinite density where time ends? Or is it something else, something not yet understood? The answers rest beyond the reach of observation, in a place where theory must guide imagination. You hover near the boundary, watching the light distort. Around Sagittarius A*, gas and dust swirl in an accretion disk, heated to millions of degrees as they spiral inward. It's not a peaceful fall, it's friction and fury, particles colliding and emitting powerful X-rays before disappearing forever. From afar, this glowing ring marks the black hole's outline. In 2022, astronomers finally captured its image using the Event Horizon Telescope, linking observatories across the planet to act as one vast eye. What they saw wasn't the black hole itself, but its shadow, a perfect ring of fire surrounding a dark center. The image confirmed what theory had long whispered, that the Milky Way's heart is a sleeping giant. Despite its power, Sagittarius A times is relatively quiet compared to the black holes in other galaxies. Some blaze with active jets that shoot across millions of light-years, fueled by voracious feeding. Ours, by contrast, consumes modestly. Occasionally, it flares a brief burst of brightness when a fragment of gas or dust crosses the event horizon, but most of the time, it rests, patient and still. If the Milky Way is a living organism, then Sagittarius A times is its pulse. Steady, slow, unseen, but essential. You drift around it, observing the strange physics that governs this region. Space near the black hole doesn't behave like anywhere else. Time moves differently here, stretched by gravity's pull. If you could hover safely at its edge, an hour for you might equal years for someone far away. Light itself bends, looping back in mesmerizing arcs. The view would be surreal stars, appearing in unexpected places, their images duplicated and twisted around the dark core. The universe here folds upon itself, yet somehow remains beautiful. Scientists still debate how these cosmic giants form. Some think they began as massive stars that collapsed early in the universe's history, growing larger by swallowing gas and stars. Others suspect they were born from the direct collapse of vast clouds, forming supermassive bodies in one sudden event. However they began, they became the anchors of galaxies, their gravity shaping the very structures of the cosmos. Every large galaxy we've ever observed has one at its center, a common thread linking billions of worlds. You can feel the quiet influence of Sagittarius A times extending far beyond the core. It governs the motion of nearby stars, stabilizes the inner bulge, and helps guide the galaxy's rotation. But its role is more poetic than destructive. It's not the monster that swallows recklessly, it's the weight that keeps the Milky Way balanced. Like a stone at the bottom of a deep pool, its gravity keeps the cosmic waters from spilling outward. The thought brings you calm. In a universe defined by expansion and movement, here lies stillness, a point of infinite gravity that unites the galaxy's chaos into order. Even the most violent forces can bring stability. The black hole doesn't destroy the Milky Way, it sustains it. Its silence is not emptiness, but equilibrium. You float above it now, watching the stars move in their timeless dance. Some will eventually wander too close, torn apart in flashes of energy that briefly illuminate the core. Others will orbit for eons, their light circling the dark center, like worshippers around a hidden altar. The galaxy's heart beats slowly, each revolution of its stars marking the passage of cosmic time. As you drift away again, the golden core fades into shadow. Behind you, the black hole's influence remains, invisible but absolute. It reminds you that even in the vastest systems, balance often hides within gravity's quiet pull. You can't see the force, but you can feel it, the way everything orbits something, the way every motion finds its center. The Milky Way turns, and at its heart lies silence. Not the silence of absence, but of harmony, a gravity so deep that even light bows to it. The galaxy doesn't just spin around Sagittarius A*, it spins because of it. And so do you. You drift farther above the golden center, and from here, the Milky Way's heart reveals a strange and beautiful shape. It isn't a perfect sphere, or even a neat circle of light. Instead, it bulges outward, like an hourglass, two lobes of brightness connected by a glowing spine that stretches through the core. Astronomers call it the galactic bar and bulge, a peanut-shaped structure that anchors the spiral arms and channels the motion of stars toward the middle. From your vantage point, the bulge glows warm and copper gold, dense with ancient suns. These are some of the oldest stars in the Milky Way, survivors from its earliest epochs, their light steady and faintly reddish. Around them, newer stars form a narrow bar that crosses the core, extending tens of thousands of light years in both directions. This bar is the engine of the galaxy's rotation, the gravitational bridge that connects the inner bulge to the spiral arms beyond. You hover near the edge of the bar, and the stars around you flow like a luminous tide. They don't move randomly. Their orbits align, following long, looping paths that twist in harmony with the bar's turn. The entire structure rotates slowly, taking about 100 million years to complete a single revolution. You can almost feel its motion beneath you, like a heartbeat echoing through the galactic disk. The Milky Way is not just spinning, it's breathing. Scientists still wonder why the galaxy developed such a shape. Theories suggest that bars form naturally in rotating disks over time, as gravity redistributes energy and angular momentum. Once a slight elongation appears, it strengthens itself, pulling stars into alignment until a clear bar emerges. This process may help feed gas toward the galactic center, nurturing star formation near Sagittarius A*. The Milky Way's bar, then, isn't merely a structure, it's a system of transport. moving energy and material where the galaxy needs it most. You imagine watching this evolution unfold over billions of years. In the beginning, the young galaxy was more chaotic, thick, turbulent, its stars swirling without pattern. Gradually, the inner regions settled, the rotation aligned, and the bar began to grow. Like a spine forming within a body, it brought order to the chaos. The Milky Way became not just a collection of stars, but an organism balanced, structured, purposeful. From within the bar, the view is overwhelming. The density of stars is so high that the night sky would never be dark. It would shimmer constantly, every direction filled with light. The stars glow amber and rose, their surfaces trembling with age. Some are swollen red giants nearing the end of their lives. Others are compact remnants, faint white dwarfs cooling slowly over time. The airless void between them hums with radiation and energy, silent but alive. Here, near the bar's center, the chemical richness of the galaxy peaks. Heavy elements, forged by generations of dying stars, saturate the gas clouds. New stars born in this region are metal-rich and bright, carrying the fingerprints of their ancestors. The Milky Way recycles itself endlessly, each generation inheriting the remains of the last. You feel as though you're standing in the galaxy's memory, the place where time folds back upon itself, where the past and present coexist in light. As you drift along the bar, you notice that it doesn't end abruptly. It merges seamlessly with the bases of the spiral arms, sending streams of stars outward like rivers feeding the sea. The arms don't begin where you might expect. They unwind gradually from the bar's tips, their stars carried by the same gravitational flow. The entire galaxy is one continuous motion, every part connected. The bar isn't separate from the arms, it's the source of their grace. Scientists still debate how long the Milky Way's bar will last. Some simulations suggest that bars may dissolve over time, disrupted by interactions with gas, stars, or passing galaxies. Others believe they endure for billions of years, reshaping but never disappearing. The evidence so far hints that ours is still growing, fed by the constant pull of the spiral's rotation. The Milky Way is still finding its shape. The peanut-shaped bulge, rising above and below the bar, tells another part of the story. It formed when stars in the inner galaxy began to oscillate vertically, lifting and sinking over time until the bulge puffed outward. Some astronomers call it a boxy bulge. Others prefer peanut bulge, a name that captures its symmetry and softness. If you could see it from above, it would resemble two glowing shells, gently pressed together, tapering toward the center. You pass through this region slowly. The stars here move in looping orbits that tilt out of the galactic plane, creating a three-dimensional ballet. You can almost sense the rhythm of it, waves of stars rising and falling in gravitational harmony. This is the heart's architecture, shaped not by violence, but by resonance. Over billions of years, the Milky Way sculpted itself into this form, guided by forces so subtle that they might as well be music. The bulge, like the bar, holds stories written in chemistry. Its stars are older and poorer in metals than those in the disk, relics from the galaxy's youth. Studying them is like reading the earliest pages of a book, whose later chapters have been rewritten again and again. Each star's composition reveals how the galaxy evolved, how it formed, enriched itself, and matured. The bulge is not just the center of the Milky Way, it's its archive. You glance back toward the spiral arms, faintly visible through the haze. From here, they look like tendrils, reaching outward, delicate and luminous. The galaxy's light flows smoothly from the outer rim to the core, every curve connected, every star part of a larger geometry. Even the smallest distortions, the warp, the streams, the dark matter halo, all play their roles in creating this perfect imperfection. Scientists still puzzle over one last mystery, whether the bar itself might one day feed the black hole at the center. As it channels gas inward, some of that material could spiral down towards Sagittarius A*, igniting new activity. Perhaps, millions of years from now, our quiet galaxy will awaken again, its heart flaring bright. You float for a moment longer, letting the image settle in your mind, the glowing peanut shape, the bar stretching outward, the spirals unfurling like petals. It's a structure born of balance, not chaos. Gravity here doesn't crush or destroy it. Organizes, composes, refines. The Milky Way's center isn't a void, it's a design, ancient and alive. You breathe deeply, as though inhaling the light itself. The galaxy's core, though hidden from view, feels closer now, almost familiar. It beats quietly, shaping everything around it, order drawn from motion, beauty born from time. You drift gently outward from the golden bulge, letting the glow fade into the faint blue of the spiral arms once more. Around you, the stars thin into hazy rivers, and among them float vast clouds, billowing, delicate, almost translucent. These are the stellar nurseries of the Milky Way, immense regions of gas and dust where new suns are born. They're the wombs of the galaxy, the quiet forges of light, where creation unfolds in slow, invisible rhythms. The first thing you notice is their color. From afar, they shine in pale hues, roses, violets, and ghostly blues, light filtered through hydrogen gas. Closer, they're darker, like storm clouds shadowed from within. Every few light years, the gas thickens into filaments and knots, where gravity begins its patient work. These dense cores are where the story of every star begins. You float through one of these clouds now, a region so large it could swallow the solar system 1,000,000 times over. The air here, though not truly air, is full of molecules, hydrogen, helium, carbon compounds, tiny grains of interstellar dust. The temperature is near absolute zero, the pressure unimaginably low. And yet, even here, gravity never sleeps. Bit by bit, it draws the particles together, nudging them into clusters, compressing them, until they can no longer resist. Inside one of those knots, the future trembles. As the gas collapses, it heats from within, pressure and temperature rising. Hydrogen atoms begin to fuse into helium, releasing light and heat for the first time. A newborn star emerges, tiny, fierce, surrounded by a swirling disk of dust. From that dust, over millions of years, planets may form. Moons, asteroids, worlds, life. Scientists still wonder exactly how the balance of forces works. How some clouds fragment into dozens of small stars, while others collapse into a single giant one. Turbulence, magnetic fields, and rotation all play roles in this delicate choreography. A small difference in density can change everything, determining whether a star will live 1,000,000,000 years or only a few million. In these nurseries, randomness and order coexist perfectly. You pass through a famous one now, the Orion Nebula, visible even to the naked eye on clear winter nights. It lies just over 1,300 light-years away, glowing in the sword of the Orion constellation. Through a telescope, it looks like a cosmic flower, a luminous heart surrounded by curling petals of gas. In its center, a cluster of newborn stars called the trapezium blazes fiercely, their radiation carving the surrounding clouds into intricate shapes. You're watching creation sculpt itself. The stars light their own cradle. As you move closer, you can see the interplay of light and shadow, the edges of the nebula flickering with ultraviolet glow. The gas here is ionized, energized by the radiation of young stars. It's a living canvas, constantly shifting as new stars ignite and old clouds dissipate. The nebula breathes in slow motion, changing shape over thousands of years. In human terms, it's eternal. In galactic terms, it's fleeting. Not far away, other nurseries whisper their stories. The Eagle Nebula, home to the pillars of creation, where towers of gas rise like stone spires. The Carina Nebula, where massive stars sculpt great caverns of light. The Taurus Molecular Cloud, where stars like our Sun may have once been born. Each is a chapter in the same grand book of renewal, the Milky Way's endless cycle of birth, life, and death. You drift past the edges of these clouds, where the newborn stars emerge from their veils. Some are still wrapped in dusty cocoons, their light faint and warm. Others have already shed their coverings, burning bright and blue. These young giants, called O-type stars, live fast and die young. They flood their surroundings with energy, stirring the gas and sometimes triggering new waves of star formation nearby. The galaxy grows not just through calm accumulation, but through feedback creation, inspiring creation, generation after generation. Scientists still debate the fine details of these processes. How do magnetic fields thread through the clouds, guiding their collapse? How do shock waves from nearby supernovae trigger or halt new stars? Even with modern telescopes, the interiors of these nurseries remain partly hidden, their hearts cloaked in dust that no visible light can pierce. Only radio and infrared instruments can glimpse the beginnings of stars, glowing faintly in wavelengths that slip through the haze. The mystery, for now, remains intact. You move through one of these dark regions, deeper still, and notice tiny points of red light flickering softly. These are protostars, still forming, their heat trapped beneath layers of dust. Around them swirl disks of matter, the beginnings of planetary systems. Some of those particles will merge into planets. Others will be lost to the void. Every flicker you see could one day host oceans, clouds, perhaps even eyes that look back at the stars. There's a quiet intimacy to this place. You can almost hear the whisper of creation, the soft hum of atoms colliding, fusing, glowing. The scale is immense, but the feeling is tender, almost human. The galaxy, for all its power, creates gently. You glide onward and see where the cycle completes. On the edges of the nebulae, old stars explode, sending shockwaves through the gas. Their remains seed the clouds with new elements: carbon, oxygen, iron, enriching them for the next generation. The Milky Way never wastes anything. Every death becomes the beginning of something else. The stars are not isolated points of light. They are steps in a cosmic lineage, each one born from the ashes of those that came before. You think of our own sun, moderate, calm, steady. It too was born in such a nursery, around 5 billion years ago, from the remnants of older stars. Long after it formed, the cluster that birthed it drifted apart, its siblings scattered across the galaxy. Somewhere out there, they still shine, separated by unimaginable distances, but connected by shared origin. In every direction, you are surrounded by the family of light. The nebula around you begins to thin, its edges glowing softly as starlight filters through. You can see the spiral arms again, rippling with new life. From here, the Milky Way feels like a living being, constantly renewing itself, breathing out starlight, inhaling darkness, creating endlessly. You drift through that breath, weightless and calm, and feel the hum of the galaxy move through you. In the quiet, you realize that creation is not loud. It doesn't thunder or roar. It's slow, gentle, patient. It happens in silence, deep within the folds of gas and time. The universe builds itself this way, not all at once, but steadily, beautifully, forever. You drift outward from the warm light of the nebulae, rising gently above the galactic plane. The stars begin to thin until they look like scattered grains of salt across a dark velvet cloth. The Milky Way's glowing arms fade below you, a pale whirlpool stretching through infinity, and then silence. The familiar disk falls away, and you enter the vast, mysterious realm that surrounds it, the galactic halo. Here, space feels larger, emptier. The light is faint, but not gone. All around you hang ancient globular clusters, dense, spherical swarms of stars bound tightly together, each one a fossil from the dawn of the galaxy. They float like glowing lanterns in the dark, scattered across the halo in a soft, even pattern. Some are bright enough to see from Earth through a small telescope. Others are hidden, faint embers drifting on the edge of time. You glide toward one now, a cluster older than imagination. From a distance, it looks like a single point of light, but as you approach, it blossoms into a shimmering sphere of thousands of stars. They're packed so densely that their cores gleam like molten metal, every star locked in a gravitational embrace. Most of them are over 12 billion years old, almost as ancient as the universe itself. These clusters are the elders of the Milky Way, survivors from an age before the spiral arms ever formed. Scientists still wonder how these clusters came to be. Did they form along with the galaxy, coalescing from its earliest clouds? Or were they remnants of smaller galaxies that merged into ours, preserved like pearls in the halo's dark sea? Each cluster tells a different story. Some, rich in metals, may have formed later, within the Milky Way's growing disk. Others, poor in heavy elements, seem older outsiders captured during the galaxy's long history of collisions. You float inside the cluster's glowing heart. The stars here are so close that if you stood on a planet within it, your night sky would never turn dark. Instead, it would shimmer with thousands of suns, each one no farther than a few light weeks away. Shadows would have color. Dawn and dusk would blend into gold. Time itself would feel heavier in such a place, where gravity weaves space into a tighter tapestry. Beyond the clusters, the halo extends outward for hundreds of thousands of light years. It's a nearly invisible sphere surrounding the Milky Way, filled not only with stars but with dark matter and hot, ionized gas. You can't see that gas with your eyes. It glows in X-rays, faint and diffuse, a ghostly aura that fills the void between galaxies. Astronomers call it the circumgalactic medium. It's the bridge between the Milky Way and the wider universe, where matter flows in and out, feeding the galaxy with new material and carrying away the ashes of old stars. You imagine this exchange as a breath. The galaxy inhales hydrogen from the cosmic web, fueling new stars. Then, it exhales supernovae and stellar winds blowing heavier elements back into the halo. The cycle repeats endlessly, maintaining the delicate balance between creation and dispersal. Even far from the bright spiral arms, the galaxy's influence lingers. The halo isn't a boundary. It's a living border, always in motion. Scientists still debate exactly how much mass the halo contains. It's difficult to measure something so faint and vast. Some estimates suggest that most of the Milky Way's total mass resides here, not in its visible stars, but in the dark matter halo that extends far beyond them. The luminous part of the galaxy is just the core of a much greater whole. You realize, as you drift through this region, that the Milky Way is like an iceberg. What you see is only its tip. The rest lies hidden, silent, immeasurable. You pass through a stream of ancient stars, remnants of a long-ago merger, still orbiting together like ghosts of their former home. Their light is weak and steady, untouched by the brightness of youth. Each one is a memory, a preserved note in the music of the cosmos. If you listen closely, you can almost hear the echo of their creation, a time when the galaxy was still forming, when gravity's hand first drew matter into shape. Farther out still, at the very edges of the halo, the stars grow scarce. You can see them spaced apart by dozens of light years, faint but persistent. Beyond them lies the intergalactic, dark, cold, deep, endless. Yet even here, the Milky Way's gravity still holds sway, binding these distant wanderers to its heart. The halo stretches farther than sight, farther than imagination, a borderless expanse of influence. Scientists have discovered that some of these outermost stars move faster than expected. Their paths hint at unseen matter, tugging from beyond. Perhaps it's another galaxy's halo overlapping ours, or the gravity of Andromeda reaching across space. The boundaries between galaxies are not clean lines, but overlapping fields, blending like mist. You realize that even separation in the cosmos is gentle, nothing ends abruptly, not even gravity. You turn to look back toward the Milky Way's disk. From this distance, it glows, like a coin of light suspended in darkness. The spiral arms are faint but clear, their soft curves turning endlessly. The bar gleams across the center. The bulge glows like a golden flame. Around it all, the halo stretches outward, like a transparent shell. It's breathtaking, a perfect harmony of structure and emptiness. In this vastness, you feel both small and infinite. You are one being among billions, yet made of the same matter as the stars that formed here billions of years ago. The calcium in your bones, the iron in your blood, all of it once drifted through this halo before finding its way into a star, then into you. The halo is not just the galaxy's outer edge, it's your ancestral home. Scientists still debate whether new stars are forming out here, in the quiet outskirts. Some evidence suggests that cold gas may condense, even in the halo's thin reaches, sparking faint bursts of light. If so, then the galaxy's story of creation continues even at its farthest borders. You look closely and think you see a flicker, a newborn star, small and blue, igniting in the distance. Against the vast silence, it shines defiantly, tender and strong. You linger here a moment longer. The view of the Milky Way from the halo is something no eye has ever seen, yet somehow you recognize it. It feels familiar the way home does, or memory, or peace. You realize that galaxies are not just places of stars. They are living histories, their shapes sculpted by time and gravity and silence. You drift slowly back toward the light, carrying with you the calm of the halo, that soft reminder that even at the edge of everything, there is connection. The galaxy breathes, and so do you. The darkness between stars is not emptiness, it's continuity. Every faint glow, every orbit, every atom belongs to the same infinite whole. You drift closer to the glowing arms again, descending through the halo's calm into the denser, busier lanes of starlight. The Milky Way hums softly here, a low vibration of energy, motion, and quiet transformation. You can almost hear it, a whisper of hydrogen clouds colliding, of magnetic fields humming across the void. But amid all that gentle activity, something has changed. The galaxy feels calmer, slower, more reflective. The great age of starbirth is waning. The Milky Way, once a vigorous cradle of suns, is beginning to rest. Every galaxy has a rhythm of creation. In its youth, the Milky Way formed stars with wild abundance, billions of new suns igniting every few million years. The gas was plentiful, the collisions frequent, the conditions perfect for life to begin its long journey. But now, billions of years later, that pace has softened. The bright nebulae, where stars are born, still exist. Orion, Carina, Cygnus, but they no longer blaze across the arms in numbers they once did. The galaxy's fires are burning low. Scientists call this phase star formation quenching. It's not an end, but a slowing, a quiet exhale after an age of creation. The interstellar gas that once flowed freely into dense clouds has grown thinner. Much of it has already been consumed, locked inside stars, or pushed outward by supernova winds. The remaining gas drifts more slowly, harder to compress. The great cosmic factories that built the Milky Way's light are running out of fuel. You pass through one of those aging regions now. The gas is faint, diffuse, like a fine mist stretched across space. A few newborn stars still sparkle within it, surrounded by shells of faint nebulae, but most of the cloud lies dormant. It's neither dying nor alive, just waiting. The galaxy is transitioning from youth to maturity, trading fire for steadiness, chaos for grace. From afar, this change is invisible. The Milky Way still glows with billions of stars, but look closely, and the difference becomes clear. The brightest stars, massive and blue, are rare now. They live fast and vanish quickly, leaving behind calm fields of long-lived red and yellow stars. The overall color of the galaxy has softened over time, shifting from brilliant white blue to warm gold. The Milky Way is aging beautifully, its light mellowing, like sunset after a long day. Scientists still wonder exactly why galaxies like ours slow their creation. Part of it may be simple exhaustion. The raw materials are dwindling. Another part may be balance the galaxy's own gravity and radiation working in harmony to prevent runaway growth. Some suggest that the supermassive black hole at the center helps regulate this process, heating surrounding gas and keeping it from collapsing into new stars. The Milky Way may be self-stabilizing, preserving its shape by letting itself rest. You imagine watching this slow transformation unfold over billions of years. The once bright arms gradually dim, their newborn clusters fading as their stars age. The spiral pattern remains, but the fiery pink of the nebulae gives way to softer yellows and reds. The galaxy becomes quieter, but not less alive. Its light becomes gentler, like candlelight after the blaze of a torch. In the stillness, creation continues, but differently now. Smaller stars form here and there, and while they burn less brightly, they last far longer. Red dwarfs, the smallest of them all, can live for trillions of years far beyond the current age of the universe. The Milky Way's next chapter will be written by these quiet stars, glowing faintly but persistently through eons. You pass through a region of such dwarfs now. Their light is subtle, barely visible to human eyes, but together they form a soft background glow. Planets circle many of them small, rocky, cool worlds that might orbit close enough for warmth. The galaxy may be calming, but it's not empty. Life, if it exists elsewhere, may find these slower suns more forgiving, more enduring. The Milky Way's aging is not decay, it's patience. Scientists still debate whether the Milky Way will reignite its starbirth someday. Collisions with smaller galaxies, like the Magellanic Clouds, could bring fresh gas and trigger new waves of formation. Or perhaps the future merger with Andromeda will stir up enough energy to create entire generations of new stars. The universe has a way of renewing itself when least expected. Even rest can lead to revival. For now, though, the galaxy seems content. You move through the disk and feel the subtle serenity that pervades it. The stars no longer rush to form. They simply endure. Supernovae are rarer, their explosions spaced by long intervals of quiet. The Milky Way is no longer a storm. It's a symphony in its slowest movement, a lullaby of light and gravity. You think of the sun, steady and calm, born late in this cosmic story. It too is a child of the Milky Way's quieter era, born not amid chaos but balance. Its stable light has given Earth the time to evolve, to nurture life, to dream of the stars that birthed it. Perhaps this slowdown was necessary for calm to exist, for reflection to bloom. If the galaxy had stayed too wild, too violent, there might never have been time for consciousness to awaken and look back at itself. The slowing of creation isn't a tragedy, it's an act of grace. It's the moment in a song when the tempo eases, allowing the melody to linger. You drift among the quiet stars and feel that rhythm settle into you. The Milky Way has entered its golden age, not blazing, but glowing. serene and wise. Scientists still measure the faint hum of hydrogen, the residual whisper of what remains to be born. They can see the gas clouds still drifting, still gathering, waiting for their turn. The galaxy hasn't finished its story. It's merely pausing between verses. In time, new light will rise again from these shadows. You breathe in the stillness. The spiral arms stretch around you like the calm ripples of a great pond after the rain has stopped. Everywhere, stars burn softly, unhurried. The Milky Way exhales, and for the first time in billions of years, it seems to rest not asleep, but content. You close your eyes for a moment and feel that same stillness within yourself. Creation may slow, but it never ends. The galaxy has not stopped. It has simply learned to move at the pace of peace. You drift through one of the galaxy's dimmer corridors, now a long, soft expanse of shadow between the spiral arms. The light fades into deep blue-gray, and the stars grow sparse. At first, it feels like emptiness, but as your eyes adjust, you begin to see faint outlines within the darkness. Vast, cold clouds hang here, immense and silent. They stretch across hundreds of light years, opaque and colorless, blocking the starlight behind them. These are the dark molecular clouds, the cold reservoirs of gas from which future stars might one day be born. They are the galaxy's waiting breath, the pause between exhalations. Up close, they look like great floating continents, their edges soft and tattered. Each one contains enough hydrogen to make thousands of suns, yet they remain still, refusing to ignite. The temperature inside is barely above absolute zero, around 10 degrees Kelvin. At that chill, even the molecules move sluggishly, their collisions too gentle to cause fusion. These clouds are the quietest places in the Milky Way. You move through one now, and the light around you vanishes entirely. Dust particles, tiny yet countless, absorb visible light and turn it into faint infrared warmth. If you could see in those wavelengths, the cloud would glow faintly red, a hidden fire beneath its frozen surface. Astronomers observe them this way, using infrared and radio telescopes to peer inside the darkness. What they see are the beginnings of structure threads, filaments, and knots of denser gas where gravity begins to take hold. Scientists still wonder why some of these clouds collapse into stars while others remain dormant. The balance is delicate. A passing shockwave, perhaps from a nearby supernova, might compress a section just enough to trigger collapse, or a collision between two clouds might create turbulence, stirring the gas until parts of it grow heavy and fall inward. But if the temperature rises even slightly, or if magnetic pressure resists too strongly, the collapse halts, and the cloud endures in silence for millions of years. Creation and stillness share the same space here. You pass through the dense center of one cloud, a region so thick that even starlight cannot penetrate. It's a realm of pure potential hydrogen molecules, clinging to icy dust grains, frozen carbon compounds drifting in slow motion. The silence is profound, not the absence of sound, but the fullness of it. Like a cathedral waiting for its first note, you can almost feel gravity's patience, its slow, invisible work. Somewhere within this darkness, tiny reactions are beginning. Hydrogen bonds to carbon, carbon to oxygen, forming complex molecules. Water, methane, formaldehyde, even amino acids. The building blocks of life are forming here, in places colder than the most barren worlds. The universe makes no distinction between the lifeless and the living. It prepares the ingredients everywhere, just in case. Astronomers study these clouds, not only for what they might become, but for what they reveal about the galaxy's rhythm. The Milky Way is full of such dark zones, interludes between the bright arms where star formation sleeps. These regions act as storage, preserving raw material for the future. Without them, the galaxy would have long exhausted its fuel. Instead, it keeps these reservoirs in reserve, ready for the next surge of creation. You imagine one of these clouds awakening. A passing shockwave sweeps through, compressing the gas. A small region collapses, then another. Tiny points of heat appear, invisible at first, then growing brighter. Within a few million years, a new cluster of stars will pierce this darkness, lighting it from within. The cloud will disperse, and the cycle will begin again. What was once invisible becomes radiant. What was silent begins to sing. You drift to the edge of the cloud now, where faint light seeps in. Against the glow of the Milky Way's background, the cloud's silhouette looks like an ink stain dark against silver. These shapes are what we see from Earth as dark nebulae. The coal sack near the Southern Cross, the Snake Nebula, the Horsehead in Orion. They look empty, but they're not. They're full of everything that has yet to be. Scientists still debate the full lifespan of such clouds. Some dissolve within tens of millions of years, eroded by radiation and stellar winds. Others endure for hundreds of millions, drifting between spiral arms, never quite reaching the threshold of birth. Their longevity depends on the galaxy's mood, its local turbulence, its magnetic fields, its nearby explosions. The Milky Way's quiet places are just as dynamic as its bright ones, though they move in slower, subtler ways. You pause near one of the smaller clouds, watching as starlight from behind filters through its edges. The light bends and reddens, scattering through dust. It reminds you of sunlight through smoke, soft, diffused, strangely beautiful. You can see the faint ripples where gravity tugs unevenly, forming thin filaments like veins. This is where the first whispers of collapse begin, invisible to any eye but gravity's. These dark clouds are the galaxy's unspoken promise. They are the silence before a song, the blank page before a poem. Every bright star you've seen, every nebula, every planet began in a place like this. The Milky Way keeps these spaces hidden, but without them, its light would have long faded. Scientists still ponder how the interplay of heat, magnetism, and time decides which clouds awaken. Perhaps it's random, perhaps it's balanced, each collapse creating just enough feedback to keep the rest asleep. The universe seems to understand moderation better than we do. You drift outward again, leaving the darkness behind. The light of the spiral arms returns, soft and familiar. But the memory of the cloud stays with you, the feeling of potential, the quiet patience of creation, waiting for its moment. You realize that even in stillness, the galaxy is alive. Its silences are not voids. They are the pauses that make the music possible. As you glide between shadow and light, you feel the rhythm of both the bright birthplaces, the dark cradles, each dependent on the other. The Milky Way breathes through contrast, illumination and rest, fire and quiet, life and waiting. You take one last look back at the cloud, floating like a dark island amid the stars. Somewhere inside it, a spark is forming slowly, invisibly, inevitably. The galaxy waits, and the silence hums with everything that will one day shine. You drift now into a region where the stars gather in delicate clusters, young, radiant, and still bound by the gravity of their shared birth. These are the open clusters of the Milky Way, shimmering islands of youth scattered throughout the spiral arms. They glisten like handfuls of jewels cast upon the dark velvet of space, each one glowing with the restless light of new life. From afar, they look like simple knots of brightness. But as you move closer, you can see that each is a family, a group of stars born from the same cloud, sharing the same age, moving together through the galaxy like migrating birds. Their orbits will one day separate them, scattering their members across the Milky Way. But for now, they remain united in their first few 100 million years. You drift toward one of the most famous, the Pleiades, also known as the Seven Sisters. Even from Earth, it's visible to the naked eye, a small dipper of pale blue stars in the constellation Taurus. But here, up close, the sight is breathtaking. Hundreds of suns gleam around you, young and bright, their light reflected off drifting dust. The cluster glows in shades of sapphire and silver, its edges wreathed in mist. The stars are still wrapped in the remnants of the cloud that birthed them, a reminder of their shared origin. You move among them, and the scale becomes dizzying. The Pleiades spans about 17 light-years, yet from within, it feels intimate, as though every star is near enough to touch. Many of them are massive and short-lived, their energy fierce. They will burn through their fuel in mere tens of millions of years, exploding as supernovae before most of their siblings have even matured. Others are smaller, gentler orange and red suns that will endure long after the cluster dissolves. Scientists still wonder how such clusters form in the first place. They know that stars are born in groups within molecular clouds, but why some remain together while others drift apart remains unclear. Gravity binds them at first, but over time, tidal forces from the galaxy's mass, along with close encounters with passing stars, tear them loose. The Milky Way both nurtures and disperses its children, guiding them into the wider cosmic sea. You pass through another cluster nearby, the Hyades, the closest open cluster to Earth. Its stars form a loose V shape in Taurus, marking the face of the celestial bull. They're older than the Pleiades, around 600 million years of age, and already beginning to drift apart. Their light is softer, tinged with yellow. You can sense the maturity in their glow, the calm after youth's brilliance. This too is the way of the galaxy: birth, connection, dispersal, and memory. Farther out, in the spiral arms, countless other clusters shine. The double cluster in Perseus, the beehive cluster in Cancer, the jewel box near the Southern Cross, all variations of the same story told across time. Each one represents a snapshot of creation's youth, a chapter in the Milky Way's family album. You pause to take in their beauty. The stars within these clusters often form planetary systems, just as our sun did. Somewhere among them, rocky worlds may already circle their parent stars, newly formed and glowing faintly with heat. Some of those planets may one day host life. It's comforting to imagine civilizations rising beneath the same starlight, perhaps even gazing up at their own cluster and wondering where they came from. Scientists still debate how many of these clusters remain bound long enough for such civilizations to arise. Most dissolve after a few 100 million years, their stars scattering into the galactic field. A few, like the ancient cluster NGC 6791, have survived for billions of years, a rarity, a testament to stability. But even those will one day fade, their members absorbed into the endless drift of the Milky Way's rotation. The galaxy recycles even its gatherings. You drift onward, and the clusters thin. Individual stars begin to dominate again, scattered like notes on a quiet page. Many of these solitary stars were once members of clusters themselves, long since separated by time. The Sun was one of them, born in a cluster around 5 billion years ago. Its siblings have long since dispersed, now scattered invisibly among the spiral arms. Somewhere out there, a handful of them still shine, sharing the same chemical fingerprint as the star that warms Earth. Scientists call them solar siblings, and they search for them across the sky, a cosmic family reunion waiting to happen. You pass through a region where the remnants of an old cluster are fading, its gravitational bonds finally undone. The stars drift apart slowly, each finding its own orbit. It's a graceful dissolution, not destruction. The galaxy takes back what it gave, redistributing its light. In time, these once close stars will mix with others, forming the smooth fabric of the galactic disk. The pattern continues. Stars gather, shine, and disperse, weaving an eternal dance. You glance back toward the clusters you've left behind, now faint pinpoints in the distance. They look so fragile against the vast dark, and yet they're the very seeds of the Milky Way's renewal. Every generation of stars owes its existence to these gatherings, temporary, but vital. Without them, there would be no planetary systems, no chemistry, no life. Scientists still puzzle over one small mystery. Why do so many open clusters form in the spiral arms? Some think the density waves that shape the arms compress gas just enough to trigger star formation in long, rhythmic patterns. The arms, in that sense, act like galactic incubators, marking the places where light begins, again and again. It's not chaos, it's choreography on a cosmic scale. You drift away slowly, the faint blue light of the Pleiades shimmering behind you. The cluster grows smaller, then disappears into the sea of stars. Its members will remain together for another 100 million years before they too scatter. But their light, young, clear, and full of promise, will continue to cross space for ages, shining toward eyes yet to be born. As you move on, you realize that every star, even when alone, carries within it the memory of belonging. The galaxy is full of these invisible connections, families separated by time, but united by origin. You are drifting not through chaos, but through continuity. The Milky Way doesn't just create stars, it creates relationships, fleeting and eternal all at once. And somewhere out there, one of those suns might look back across the spiral arms and see the faint glimmer of your own. You glide deeper into the Milky Way's vast spiral arms once more, where the light grows richer and warmer, woven through with the quiet pulse of energy. Around you, space is alive with the remnants of ancient stars, vast bubbles of gas, scattered elements, and glowing shells of debris expanding into the dark. These are the supernova remnants, the echoes of stars that lived fast and ended in brilliance. From a distance, they look like soft halos of light, but as you move closer, they reveal themselves as intricate webs, threads of gas and dust, glowing faintly in red, green, and violet hues. The shock waves that created them ripple outward at thousands of kilometers per second, sculpting the interstellar medium, stirring the quiet gas into motion. You can almost feel the resonance of those ancient explosions, long faded but never fully gone. Each remnant tells a story of transformation. When a massive star exhausts its fuel, its core collapses in an instant, releasing more energy than the sun will emit in its entire lifetime. For a brief moment, it outshines the entire galaxy, a single beacon of fire visible from millions of light years away. Then it fades, leaving behind either a dense neutron star or a black hole, surrounded by a shell of expanding debris. You drift now through one of the most famous of these remnants, the Crab Nebula, the ghost of a star that exploded in 1054 CE. It was seen on Earth nearly 1,000 years ago, a guest star so bright it was visible in daylight for weeks. Now, what remains is a delicate structure of filaments and tendrils, glowing with soft blues and pinks. In its center lies a pulsar, a spinning neutron star the size of a city, rotating 30 times per second, sending beams of radio and X-ray light into space. The pulsar is the heartbeat of what was once a Sunday. You move closer and can almost feel its pulse. Each rotation releases a burst of energy that ripples through the nebula, lighting the gas in shifting waves. The Crab Nebula is not still, it flickers and breathes, a remnant that refuses to fade. Even after 1,000 years, its light continues to shape the space around it, compressing gas, stirring dust, seeding the next generation of stars. The death of one gives rise to the possibility of many. Scientists still wonder exactly what triggers a supernova's final collapse. The equations are known, but the details remain elusive. Some stars seem to skip their predicted endings, collapsing directly into black holes without visible explosions. Others shatter more violently than expected. Even now, astrophysicists refine their models, trying to predict which stars will die quietly and which will burst. The Milky Way has seen countless such deaths, yet each remains a mystery. You pass through the fading edge of the nebula and enter open space again. Here, the shockwave has thinned into invisible ripples, waves of magnetic energy, and particles racing outward. These waves enrich the interstellar medium, spreading elements forged in the heart of the star: carbon, oxygen, silicon, iron. The calcium in your bones, the oxygen in your breath, the iron in your blood, all were born in such explosions. Every living thing carries the memory of supernovae within its atoms. You think about the paradox of it all, that creation and destruction are the same process on a galactic scale. The Milky Way shines because its stars die. Without these explosions, the galaxy would be sterile, nothing more than endless hydrogen and helium drifting in the void. It's the violence of supernovae that makes life possible, that turns simplicity into complexity. Every beautiful thing you see is the echo of something that once ended. You approach another remnant, this one older and more diffuse, the Vela supernova remnant, sprawling across the southern sky. Its filaments stretch like cobwebs of light, luminous yet ghostly. The shockwave that formed it has long since cooled, leaving behind intricate tendrils of glowing hydrogen. In the center, a small neutron star spins quietly, nearly invisible. It was once a sun, and now it's a diamond-hard sphere of neutrons, barely 20 kilometers wide, but with a mass greater than the sun's. The pressure inside it is unimaginable. A teaspoon of its material would weigh billions of tons. You float past it, humbled by the contrast. Such destruction, such peace. The Milky Way's violence is slow, elegant, and creative, all at once. Even now, astronomers detect new supernova remnants, hidden within the dust-faint rings and bubbles that tell of ancient deaths. Some occurred before life ever began on Earth, their light just now reaching us after millions of years. Scientists still debate how frequently such explosions occur in our galaxy. On average, they estimate 2 or 3 every century, though many are obscured by dust and never seen. Somewhere in the Milky Way, another massive star may already be nearing its end, its core preparing to collapse, its final light waiting to ignite the night. If it happens close enough, Earth's skies will briefly host a new star brighter than all the rest, a reminder that the universe is always rewriting itself. You drift onward, following the faint traces of energy left behind by these ancient events. The interstellar gas here glows faintly, enriched and alive. In a few million years, it may cool and collapse again, forming new stars and planets. The Milky Way is a master of recycling. Nothing is wasted, not even death. As you glide between the faint wisps of these remnants, you sense the rhythm of it all, the heartbeat of destruction and creation, expansion and renewal. Every death leaves behind the material for another life. Every explosion sends its echoes outward, shaping the galaxy's breath. The space around you grows quiet again. The remnants fade into darkness, their energy spent. The stars ahead shine calmly, unaware of what birthed them. You realize that if you could listen to the galaxy over eons, you would hear it inhale and exhale, with every supernova, each one a note in an endless symphony. You look back at the Crab Nebula, now a faint, distant shimmer, and feel a strange comfort. The stars are mortal, but their deaths are not endings. They are transformations, moments of brilliance that ensure the galaxy never grows still. You, too, are made of their remnants, carrying their light in your very being. The Milky Way glows not despite its losses, but because of them. Its beauty lies in the cycle itself. Birth from death, light from collapse, creation from decay. You drift onward through that eternal rhythm, weightless and calm, surrounded by the quiet aftermath of eternity's most magnificent explosions. You drift beyond the glowing filaments of the supernova remnants, leaving behind the colorful traces of destruction and renewal. Ahead, the stars settle into calm order again, shining with steady light. Here, the Milky Way feels different, less chaotic, more mature. These are the middle-aged stars, the ones that have reached equilibrium, their fires balanced perfectly between gravity and pressure. Among them lies one you know well, a modest yellow sun, unremarkable from a distance, yet precious beyond measure. This is our sun, one of the galaxy's quieter lights. You approach it as though visiting an old friend. From afar, it's a small bright pearl within the Orion Arm, tucked safely between two larger spiral lanes. Around it, 8 planets revolve, each tracing its own path in silence. The sun's warmth reaches across billions of kilometers, shaping a system of light and shadow, wind and stone. You pass through the outer layers of its glow, where particles stream outward in every direction. This is the solar wind, a river of charged energy flowing through the Milky Way's greater sea. The sun hums, though you can't hear it. Its surface trembles with waves of heat and magnetism, each one rippling outward like the breath of a sleeping giant. To human eyes, it looks constant and serene, but up close, it's alive with motion. Great loops of plasma arc through its corona. Spots of darkness bloom and fade on its surface. Every 11 years, it cycles through calm and storm, its magnetic fields twisting and resetting, its energy building and releasing in flares. Scientists still wonder about the full depth of the sun's rhythms. They study its oscillations like musicians tuning an instrument, listening for subtle shifts that reveal its internal workings. The sun's heart is invisible, but through its surface vibrations, astronomers can map its layers: the core where fusion blazes, the radiative zone where energy drifts outward, and the convective layer, where rising heat churns like water in a great pot. The patterns are as intricate as they are eternal. You move closer now, into the region of light itself. The temperature climbs, but you remain unharmed, drifting in the calm of imagination. The photosphere stretches below like molten gold, boiling slowly, each cell the size of continents. Here, hydrogen fuses into helium, releasing energy that has spent tens of thousands of years traveling from the core to this surface. In an instant, that light leaps outward across planets, moons, and endless space, eventually crossing the void to reach the tiny world called Earth. You pause, thinking about that journey. Every ray of sunlight that warms your face began its life in the heart of the sun, born from atoms colliding under unimaginable pressure. It took millennia to rise through the dense layers, yet only 8 minutes to travel the final 150 million kilometers to Earth. The light you see every day is ancient and young, at once a moment of fusion made visible across time. Scientists still debate how the sun's steady output has remained so stable for billions of years. Many stars of its size fluctuate wildly, but ours has maintained balance almost perfectly. This constancy is what makes life possible. The sun is neither too calm to stagnate, nor too violent to destroy. It sits in a golden equilibrium, patient and enduring. You drift past Mercury, a scorched world of craters and heat, Venus, wrapped in clouds of acid and fire, then Earth, blue and breathing, its oceans shimmering in reflected sunlight. You feel a strange tenderness as you pass the realization that everything you know, everything that thinks or feels, owes its existence to this quiet yellow star. Its light is the thread that connects every living thing. Beyond Earth, The planets stretch outward. Mars with its red deserts and pale skies, Jupiter with its roaring storms, Saturn ringed with icy grace. Each world, in its way, holds a memory of the sun's birth. The planets are its children, shaped from the same disk of gas and dust that once swirled around it. The faint traces of that origin still linger in the asteroid belt, in comets wandering the outer reaches, in the distant halo of frozen bodies called the Oort cloud. The sun's family extends far into the darkness, its influence spanning light years. Scientists still wonder what lies beyond the edge of that influence, the boundary where the solar wind meets the interstellar medium. They call it the heliopause, a frontier where the sun's breath ends and the galaxy's begins. The twin Voyager spacecraft have crossed it, sending back whispers of that distant realm, a place where the particles of one star give way to the currents of billions. Beyond that invisible wall, the sun becomes one voice among many, its song blending into the Milky Way's chorus. You drift outward past that frontier now, and look back. The solar system glows softly against the backdrop of stars, a golden cocoon wrapped in faint plasma light. From here, the sun is just another star, bright, but not unique. And yet, to you, it feels deeply personal. It's home. Every element in your body, every thought, every heartbeat is a note in its long symphony. You carry its warmth within you, a reminder that even the smallest life is tied to the great engines of the cosmos. You think about how the sun will change over time. In about 5 billion years, it will exhaust its hydrogen fuel and expand into a red giant, its outer layers swelling to engulf Mercury and Venus. Earth's oceans will boil away, its skies will fade. Then, after millions of years, the sun will shed its outer layers, leaving behind a small, dense white dwarf, a cooling ember that will shine faintly for trillions of years more. Its light will dim, but not vanish. Even in death, it will illuminate. Scientists still debate what the far future holds for such remnants. Will they eventually cool into black, invisible stones? Or will collisions and cosmic processes recycle their matter into new stars? The answers lie beyond the current age, written in equations we have only begun to glimpse. What's certain is that the sun, like all stars, is part of the Milky Way's great cycle, a flame that will one day become ash, and from that ash, perhaps, new fire. You linger one last moment near the sun's light, letting its warmth bathe you. Around it, the planets continue their slow, endless dance. The light that leaves here tonight will travel outward through the galaxy, brushing against dust clouds, illuminating nebulae, blending with starlight from billions of others. The Milky Way is a web of illumination, each star feeding the next. You turn away and drift back toward the galaxy's wider sea. The sun fades into distance, one spark among countless others. Yet somehow, you can still feel it, a pulse of warmth that follows you, a memory of home. The light that fills the galaxy is not just energy, it is heritage, shared across every corner of the sky. The sun is ordinary, yes, but only in the way the heartbeat is ordinary. Constant, life-giving, essential. It burns quietly at the edge of the Milky Way, and because of it, a small blue world learned to look up and wonder. You drift slowly beyond the familiar neighborhood of the sun, past the last icy bodies of the Oort cloud. Behind you, the solar system fades into a single point of light, a warm spark in the vast ocean of the Milky Way. Ahead, the darkness deepens again. But as your eyes adjust, you begin to see something subtle, something vast and intricate: the interstellar medium, the quiet matter that fills the space between stars. At first glance, it looks empty, but in truth, this space is alive. It is filled with atoms, molecules, dust grains, magnetic fields, and streams of energy that thread the galaxy together. The interstellar medium is the Milky Way's bloodstream, circulating material between stars, feeding new births and carrying away remnants of the old. It is so diffuse that a cubic centimeter of space might hold only one atom, and yet, stretched across hundreds of thousands of light years, it shapes the galaxy's fate. You move through it gently, and it feels like drifting through fog so thin you can't see it but somehow know it's there. Occasionally, you catch faint wisps of gas glowing softly, where ultraviolet light from nearby stars excites hydrogen atoms. These faint clouds form emission nebulae, the delicate pink and violet veils that mark the active regions of the spiral arms. Their beauty is fleeting. The radiation that illuminates them also tears them apart over time. Between those glowing regions lie vast stretches of cool, neutral hydrogen gas. Invisible to the human eye, they reveal themselves only through radio waves. For decades, astronomers have listened to the Milky Way in this wavelength, 21 centimeters long, a spectral line of neutral hydrogen. It's like hearing the galaxy breathe. These radio signals allow scientists to map the spiral structure, tracing where the arms twist and curve, even through the thickest dust. You think of it as sonar, in the dark, the way lightless waters can still be understood, through echoes. The Milky Way is speaking constantly, just not in a language of light. It hums in radio frequencies, whispers in infrared, flashes in X-rays. Every wavelength tells a different story, a different layer of its being. Scientists still wonder about the hidden balance of forces within this interstellar medium. How does it remain stable when the galaxy is constantly stirring it? Supernovae inject energy, stars pour out radiation, magnetic fields twist like invisible ropes, yet somehow the chaos holds equilibrium. It's as though the Milky Way understands how to breathe between storms. You pass through one of the superbubbles, vast cavities carved by multiple supernovae over millions of years. The gas here is hot and thin, filled with shock waves that ripple outward, pushing cooler material into dense walls at the edges. These bubbles are the lungs of the galaxy, exhaling heat and metals, inflating and contracting as stars are born and die. The scale is impossible. Each bubble can span hundreds of light years, drifting for tens of millions more before merging with others. You can almost see the cycle now, laid out before you like a slow heartbeat. Gas collects into molecular clouds, collapses into stars, which then shine, explode, and return their matter to space. That matter cools and condenses again, starting the process anew. The interstellar medium is not a void, it is the womb of eternity. Scientists still debate how magnetic fields thread through this grand system. Invisible lines run through the gas like strands of silk, guiding its motion, influencing how it collapses into clouds. Even the light you see is polarized by these fields, twisted slightly as it passes through. The galaxy is woven from magnetism as much as from matter. These unseen threads connect stars across thousands of light years, linking even distant regions in subtle harmony. You drift through a denser patch of interstellar dust now, and the light dims. Tiny particles, carbon, silicates, ice float like smoke in the airless dark. Each one is a microcosm, perhaps formed in the outflow of an ancient star. Over time, these grains clump together, forming new planets, new moons, new comets. Every world that ever existed began as dust in such clouds. You reach out, as if to touch one, and realize how fragile and sacred such simplicity can be. A small star glows nearby, illuminating the gas around it in a faint blue halo. The light scatters, turning the surrounding dust into a reflection nebula. These are the quiet cousins of the bright emission nebulae clouds that do not shine by their own energy, but by the light they borrow. The effect is gentle, dreamlike, as if the galaxy itself were painted in watercolor. You pass through it slowly, feeling the starlight brush past like wind. The interstellar medium also carries cosmic rays, charged particles moving near the speed of light. They come from supernovae, pulsars, and distant galaxies, raining constantly through space. When they strike Earth's atmosphere, they create showers of secondary particles, tiny, invisible reminders of the universe's ongoing conversation. Every second, thousands pass through you. You are part of that dialogue, your atoms forever touched by the galaxy's invisible rain. Scientists still struggle to understand how these cosmic rays influence galactic evolution. Some believe they play a role in heating the gas, shaping magnetic fields, or even controlling the rate of star formation. The galaxy, it seems, is not governed by gravity alone, but by a tapestry of forces, some visible, some not, all interwoven in perfect tension. You glide onward, and the darkness deepens once more. Yet, even here, where the starlight grows faint, there's movement, tiny waves, pressure shifts, whispers of light unseen. You realize that the interstellar medium is not static. It's a fluid, constantly flowing, shifting, and evolving. It carries the essence of everything the galaxy has ever been. If you could listen long enough, you might hear the faint murmur of its motion, the echo of ancient explosions, the sigh of new stars forming, the hum of magnetic fields stretching through infinity. The Milky Way is not a still picture. It's a living process, a river of matter and energy that never ceases to flow. You turn and look back toward the spiral arms you've crossed. They no longer look like structures of stars, but like currents within this greater sea. You see now how every arm, every nebula, every cloud is just a pattern on the surface of a much deeper, unseen ocean. The interstellar medium is that ocean, the soft fabric that connects all things. As you drift through it, you feel no edges, no boundaries. The space between stars is not empty at all. It's full of presence, quiet, invisible, sustaining. And as you glide through that calm, you understand something profound. The galaxy's greatest beauty is not in its stars, but in the silence between them. You continue drifting through the Milky Way's invisible ocean, the interstellar medium stretching endlessly in every direction. Around you, faint light flickers tiny ripples of brightness that seem almost alive. As you move closer, you realize they are not stars, not gas, but the pale glows of cosmic dust scattered throughout the galaxy. It hangs like a fine mist, delicate and ancient, shaping the way you see everything. Cosmic dust is the quiet sculptor of the Milky Way. Each grain, no larger than a smoke particle, floats freely through space, drifting between stars for millions of years. Yet together, these grains shape the light of the entire galaxy. They absorb starlight, scatter it, and re-emit it as a soft infrared glow. Without this dust, the Milky Way would look sharper, colder, less mysterious. But because of it, the galaxy wears a veil, a shimmer that softens every edge. You drift through a dense patch of it now, and the view changes completely. The starlight dims, replaced by a golden haze. You can almost taste the texture of it, a fine, weightless powder made of silicates, carbon, ice, and metal compounds. These grains formed in the outer layers of dying stars, red giants, and supernovae that shed their material into space. Over eons, those fragments merged and broke apart, carried by stellar winds until they filled the galactic disk. The dust is both debris and seed ashes from one generation, foundation for the next. Scientists still study how these tiny grains evolve. They know that dust helps new stars and planets form, providing the surfaces upon which molecules can cling and combine. Water, methane, and ammonia freeze onto dust grains in cold clouds, creating the first hints of organic chemistry. In this sense, every living thing begins in dust. The same particles that dim starlight also harbor the ingredients for life. You pass through a region where the dust forms long tendrils, dark filaments silhouetted against the glow of distant stars. These are infrared cirrus, the faint, web-like structures that make up much of the galaxy's hidden architecture. To the naked eye, they are invisible. To infrared telescopes, they appear like lace spread across the night. The Milky Way is stitched together by these filaments, threads of shadow that hold the luminous fabric in place. The dust isn't evenly spread. It clumps and drifts, pushed by radiation pressure and stellar winds. In some regions, it gathers into dark nebulae, the same clouds you passed earlier, thick enough to block all visible light. In others, it floats freely, thin enough to simply tint the starlight passing through. The Milky Way's signature glow, the soft, hazy band across the night sky, is shaped as much by dust as by stars. You realize that what humans see from Earth is not just light, but light filtered through memory. You pause and turn toward the galactic center, where the density of dust is highest. Even powerful telescopes struggle to see through it, which is why radio and infrared astronomy became so vital. By looking beyond visible light, scientists can pierce these opaque lanes and uncover what lies hidden: newborn stars, black holes, and the structures of the spiral arms. It's as if the galaxy's true self can only be revealed when you learn to see in silence. Scientists still wonder about the balance of dust in the Milky Way. It seems to appear and vanish in equal measure, created by old stars and destroyed by radiation and collisions. Each grain might last only a few 100 million years before being vaporized or shattered. Yet somehow, the galaxy always maintains enough to weave its luminous fog. The Milky Way, it seems, knows how to replenish its own shadows. You float past a region where the dust glows faintly on its own. The light here is infrared soft, invisible to human sight, but warm and soothing. The energy comes from countless tiny collisions, each grain absorbing a photon and re-emitting it as heat. The entire galaxy emits such radiation, a gentle thermal hum that fills the cosmos. Even the darkness between stars is warm in its own way, whispering the residue of light. You remember how the phrase, "From dust you came, and to dust you shall return," was once spoken of life. Here, it takes on a cosmic truth. The atoms in your body, carbon, oxygen, silicon, were once locked within such dust grains. They drifted through space until a new star's gravity pulled them together, forming worlds, oceans, and breath. You are not separate from the dust. You are made of it. You are the Milky Way, remembering itself through consciousness. You reach a thin patch now, where starlight breaks through in golden rivers. The dust scatters the light into soft halos, making the stars shimmer like they're underwater. This scattering is why distant starlight reddens as it reaches Earth. The blue wavelengths are absorbed, leaving behind the warmer tones. Every sunset you've ever seen is, in a way, the galaxy's fingerprint written in color. Scientists still debate how dust behaves in the most extreme environments near black holes, inside supernova remnants, or at the edges of the galactic halo. Some evidence suggests that even there, new dust forms, as if the universe refuses to let go of its habit of rebuilding. Destruction, in cosmic terms, is just another stage of creation. You drift past a brighter pocket, where young stars shine through holes in the dust, their light scattering outward in blue halos. You think of how fragile this balance is, the interplay of light and shadow, creation and concealment. Without dust, the galaxy would blaze with harsh brightness. With too much, it would fall into obscurity. The Milky Way exists in that perfect middle ground, where beauty is born from imperfection. The view grows clearer again as you leave the densest lanes behind. The stars sharpen, the arms stretch in luminous arcs, and the faint haze lingers only as a soft glow in the distance. Yet you know now that even this clarity depends on dust, that every sharp edge you see is shaped by what hides behind it. The galaxy drifts beneath you, an ocean of light veiled in shadow, dust, gas, gravity, and time, all working together to create something that feels both eternal and tender. You realize that the Milky Way's true brilliance isn't in its light alone, but in the harmony between what shines and what hides. You exhale softly, as if trying not to disturb the balance. Even the smallest mote of cosmic dust, floating unseen between the stars, carries the story of creation. The galaxy doesn't sparkle. Despite the dust, it sparkles because of it. You move farther into the outer spiral arms now, where the Milky Way stretches thin and delicate. The bright, crowded lanes near the core fade behind you, and the stars become faint, scattered like seeds drifting on a breeze. Out here, in the quiet outskirts, you begin to sense the edge of the galaxy, the place where order gives way to the open dark. Yet even at its edge, the Milky Way still breathes, still hums with the faint pulse of motion. You pause to take in the view. From this distance, the spiral pattern looks softer, less defined. The arms begin to blur into faint streams, curving away into space like the wisps of a fading smoke ring. But look closer, and you'll see that the galaxy doesn't end cleanly, it simply thins, its stars becoming fewer and colder. The outer disk stretches on for tens of thousands of light years beyond the visible glow, filled with ancient, metal-poor stars that trace the fading rhythm of the Milky Way's heartbeat. Scientists once thought galaxies had sharp boundaries, but the Milky Way refuses such neat definitions. It tapers gradually, its stars blending into the stellar halo beyond. The edges are porous, overlapping with the gravitational pull of nearby galaxies. It's as if the Milky Way never quite learned where to stop, its gravity still reaching, its light still stretching, its influence still felt far beyond its visible rim. You drift among these outer stars now, and the stillness feels deeper than anywhere else. There are no nebulae here, no clusters, no glowing clouds. The airless dark is almost pure. The few stars that remain are old and faint, their orbits elongated and tilted at odd angles, as though they've been tugged and twisted by unseen hands. These stars are ancient immigrants, captured from smaller galaxies that once ventured too close and were torn apart. You pass through one such stream of captured stars, the ghost of a long-vanished galaxy. It's a river of light barely visible against the black, looping around the Milky Way like a forgotten ribbon. Astronomers have mapped many such streams: Sagittarius, Helmi, GD1, each one the remains of a galactic merger. Over billions of years, the Milky Way has absorbed dozens of smaller systems, their stars now blended into its outer halo. The galaxy you see today is not a single creation, but a mosaic of many. Scientists still wonder how far the Milky Way truly extends. Some measurements suggest its stellar disk could span more than 170,000 light-years, nearly twice what we once believed. And beyond even that, a diffuse halo of gas stretches hundreds of thousands of light-years further, touching the edges of the local group, where Andromeda's influence begins. The Milky Way is not an island, it's part of a vast archipelago of galaxies, all connected by gravity's invisible threads. You can almost feel those connections now, like faint tugs in the fabric of space. The pull from Andromeda, our nearest galactic neighbor, is gentle but steady. In about 4 billion years, the two galaxies will meet, their stars passing harmlessly through each other, their gas clouds colliding and igniting new bursts of star formation. What will emerge from that cosmic encounter will be something entirely new, a single, larger galaxy, sometimes called Milkomeda. The Milky Way's story, it seems, will end not in isolation, but in union. You drift farther outward still, until the galaxy begins to flatten into a single glowing disk below you. From here, it's breathtaking, an ocean of light suspended in the dark, its spiral arms faintly outlined by rivers of dust. The core glows golden, the arms shimmer blue-white, and all around, a soft halo of stars drapes like mist. It's both infinite and intimate, as if you're seeing not an object, but a living presence. Scientists still debate how such magnificent structures maintain their shape. The spiral arms are not rigid, they're density waves, regions where stars slow down and bunch together before moving on. The stars themselves are always changing places, moving in and out of the pattern like dancers in an endless waltz. What you see when you look at the Milky Way is not fixed form, but perpetual motion, a frozen wave in the flow of cosmic time. You realize how deceptive stillness can be. The stars you see now are moving at hundreds of kilometers per second, each tracing an orbit around the galactic center that takes hundreds of millions of years. And yet, the overall pattern remains, a self-renewing geometry held together by gravity and time. The galaxy is a paradox, chaos and symmetry entwined. You let your gaze wander outward, past the faint outermost stars, into the darkness that follows. Here, the Milky Way's light fades completely, but its gravity still extends far beyond. Invisible dark matter surrounds you, a halo of unseen mass stretching hundreds of thousands of light years into the void. It binds the stars, the gas, the dust, and even you to this spinning family of light. The silence out here is profound. The galaxy glows behind you, and ahead lies intergalactic space, cold, vast, and mostly empty. The faint light of other galaxies glimmers at the horizon. Andromeda to one side, the Triangulum Galaxy on the other, and 1,000 dimmer points beyond. They seem motionless, but each one is a Milky Way in its own right, full of stars, planets, dust, and mysteries. Scientists still ponder how these great structures communicate, how their halos overlap, how their gases exchange, how their dark matter halos intertwine. The universe, they believe, is a web of galaxies, each one connected to others by threads of invisible matter. You are standing, metaphorically, on one of those threads, feeling the faint pull of the cosmos on every side. You turn back for one final look at the Milky Way. From here, it's a spiral of light, adrift in an ocean of black, its edges glowing faintly, its core burning steady. Every star you've passed, every cloud, every soundless burst of creation, all of it fits within that single shape. And within that shape lies every memory, every world, every dream that ever was. You realize that even here, at the edge, the galaxy does not feel distant. It feels whole. The stars within it are bound not by proximity, but by belonging. You, too, belong to it not as an observer, but as a participant. The atoms of your body were forged in its stars, carried through its clouds, shaped by its gravity. You are the Milky Way, and it is you. You drift a little farther still, until the galaxy begins to look like a memory itself, a swirl of light, both fragile and eternal. The Milky Way does not end here. It only fades, merging with the greater universe that surrounds it. You hover now beyond the Milky Way's faintest edge, where its soft glow thins into the wider sea of the cosmos. From this distance, the galaxy looks small, a luminous whirlpool suspended in velvet black. You can see the entire spiral, its golden core, its blue-white arms, its faint dust lanes coiling like mist. But around it stretches something greater still, the quiet expanse of intergalactic space. It's not empty, though it feels that way. Here, the distances grow incomprehensible. The nearest star of another galaxy lies millions of light years away. Between galaxies float thin clouds of gas, drifting endlessly through the void. Scattered throughout this emptiness are faint clusters and filaments of matter, the scaffolding of the universe. You are seeing the Milky Way's neighborhood, its cosmic village within the local group. The nearest neighbor glows softly to one side, the Andromeda Galaxy, M31, faint and elegant. Even from here, it looks majestic, a massive spiral larger than our own, its arms wound tightly around a brilliant core. You can see tiny points of light orbiting it, its own system of dwarf galaxies, moving in slow, hypnotic arcs. Between you and Andromeda lies a vast gulf of 2.5 million light-years, yet the two galaxies are already connected by gravity, slowly pulling toward each other. Their fates are intertwined. Scientists have measured this approach with exquisite precision. Each year, Andromeda moves about 110 kilometers closer to the Milky Way. It's a slow waltz, invisible to the naked eye, but relentless. In roughly 4 billion years, the two galaxies will meet. The collision won't be violent. In the way you might imagine, stars are so far apart that very few will actually collide. Instead, their orbits will shift and stretch, their shapes will distort, and great tidal streams of stars will spill into intergalactic space. The night skies of any surviving worlds will blaze with beauty beyond words. You can almost imagine it, two great spirals approaching, their arms intertwining, their halos merging. Over hundreds of millions of years, they will pass through one another, separate, then fall together again, drawn by mutual gravity. In time, they will fuse completely, forming a single elliptical galaxy. Astronomers have already given it a name, Milkomeda. The stars of both systems will mingle, the black holes at their centers will merge, and a new cosmic form will be born. Scientists still wonder what role dark matter will play in that encounter. Their simulations suggest the invisible halos surrounding both galaxies will collide first, their gravitational fields blending long before the visible stars touch. The universe, it seems, is always guided by what cannot be seen. You realize that even the grandest cosmic events begin quietly, with invisible motion, just as the tide turns before it's felt on shore. You drift closer to Andromeda now, crossing the endless gulf that separates it from the Milky Way. The journey feels serene, yet timeless light itself takes millions of years to cross this space. Along the way, you pass small galaxies caught between the two giants, M32, compact and bright, and M110, its fainter companion. These dwarfs are like satellites, pulled gently between gravitational giants. You can sense the subtle tension between them all, a vast, slow dance, choreographed by time. When you finally reach Andromeda, you find it both familiar and foreign. Its spiral arms resemble the Milky Way's, but everything here feels sharper, denser, more luminous. The stars crowd together near the core, their light blending into a brilliant haze. Around its edges, you can see faint streams of stars, evidence of past mergers, smaller galaxies torn apart and absorbed. Andromeda, too, carries scars of its long history, just as the Milky Way does. Scientists still debate which of the two galaxies is larger. Some measurements show Andromeda as the heavier. Others suggest the Milky Way's dark matter halo gives it the edge. But in truth, size matters less than kinship. The two are siblings, born from the same cosmic filament billions of years ago. They have grown apart, drifted, and now, like distant relatives, they are finding their way back to one another. You move between them now, pausing midway, in the vast emptiness that joins their gravitational fields. Around you, the intergalactic medium glows faintly with X-rays, a thin plasma connecting the galaxies like a cosmic bridge. This is not emptiness but communion. Hydrogen atoms stretched thin but continuous, forming the invisible web that binds the local group together. Even across millions of light years, the universe remains connected. You glance beyond Andromeda and see other members of this galactic family, the Triangulum Galaxy, small but bright, shimmering with clusters of young stars. Beyond that, Faint smudges mark dwarf galaxies like Leo I and Sagittarius Dwarf, orbiting on the periphery. Together, they form a network of motion, each one circling or drifting through the same shared gravity. The local group is not chaos, it's a quiet cluster of companionship, bound not by proximity, but by belonging. Scientists still debate the full extent of this family. Some think the local group contains around 50 galaxies, most of them tiny and faint. Others suspect there may be hundreds, too dim for current telescopes to see. Each one, no matter how small, carries its own history of star formation, collision, and change. Even the smallest dwarf galaxy is a universe unto itself, with billions of suns and endless stories. You turn back toward the Milky Way, now distant but radiant. Its spiral arms shimmer faintly, like a seashell reflecting light. Beside it, Andromeda glows in parallel, the two galaxies suspended like twin lanterns in the night. Between them lies emptiness, but also the promise of union. In time, they will merge, their stars blending into a new creation, their histories folded into one another, like pages of the same book. You float between these two giants and feel an immense calm. Everything moves slowly here. The future stretches billions of years ahead, unhurried, serene. The Milky Way and Andromeda are patient. They have always been patient. The cosmos doesn't rush its transformations. It lets them unfold like tides, each wave blending softly into the next. You take one last look around the faint glimmer of dwarf galaxies, the long threads of intergalactic gas, the soft hum of gravity's embrace. It all feels strangely intimate, as though the universe is holding its breath between heartbeats. Scientists still search for meaning in this cosmic calm. Some see it as the prelude to change, others as a perfect balance that will last for ages. But to you, drifting quietly in the void, it feels like peace, the space between notes, the silence that lets the music exist. And far behind you, your home galaxy turns slowly on its axis, a spiral of light spinning gently through eternity, waiting for its companion to arrive. You linger for a long while between the two galaxies, the Milky Way and Andromeda, watching them shine across the void, like twin lanterns suspended in infinite dusk. Around them, faint points of light glimmer, each one a smaller galaxy, circling quietly within the gravitational field of the local group. It's a tranquil sight, dozens of islands of light, floating in a sea of black. But beneath this stillness, motion never ceases. Every galaxy drifts, pulled and guided by unseen hands. And together, they all move towards something greater, still the heart of the Laniakea supercluster, the immense cosmic continent that the Milky Way calls home. From this vantage point, you can begin to see the grand structure of the universe. Galaxies bound into groups, groups gathered into clusters, clusters woven into filaments that stretch across billions of light years. The Milky Way is just one thread in that tapestry. The Laniakea supercluster, a Hawaiian word meaning immense heaven, contains over 100,000 galaxies spread across 500 million light years. And at its center lies a region of gravity so subtle yet so strong that it pulls everything toward it, the mysterious great attractor. You turn your gaze toward that direction now, and the scale of it all becomes almost impossible to hold. What looked infinite before expands again. The universe seems to open like a flower, revealing deeper layers of pattern. Galaxies line up along luminous strands, forming cosmic filaments that stretch across the darkness like veins of gold in obsidian. Between them lie immense voids, regions of almost nothing, each tens of millions of light years wide. The contrast between fullness and emptiness feels sacred. Scientists still puzzle over how such grand structures formed from the smooth, uniform energy of the early universe. They believe it began with tiny ripples in density, small variations in the cosmic microwave background, left behind after the Big Bang. Over billions of years, gravity amplified those ripples, drawing matter into threads and nodes, forming the cosmic web we see today. The Milky Way, like every other galaxy, sits at one of those intersections, part of a vast, interconnected lattice that spans the universe. You drift along one of these filaments now. The galaxies within it move like droplets on a thread, flowing gently toward clusters where gravity is strongest. One such destination lies ahead, the Virgo cluster, a colossal assembly of over 2,000 galaxies, about 54 million light-years away. It gleams faintly, a congregation of light too large for the mind to contain. The Milky Way itself is bound to it, drawn slowly inward along the great river of gravity that defines our supercluster. You are part of that current, though you'll never feel it. The Virgo cluster is dazzling even from afar. Elliptical galaxies, smooth, golden, and massive, fill its core, surrounded by spirals like ours, scattered like petals. The cluster radiates X-rays from its vast cloud of hot gas, and at its heart lies another supermassive black hole, 100 times the mass of the one in Sagittarius A*. Yet even here, the same rhythm continues, stars forming, dying, collapsing, and reborn. The scale changes, but the pattern endures. Scientists still wonder what exactly the great attractor is. Some say it's simply the dense region near the center of Laniakea, where many clusters converge. Others suspect there may be an even larger structure beyond it, something we cannot yet see, its light obscured by the dust and stars of our own galaxy. The Milky Way, ironically, hides part of the cosmos behind its brilliance. What lies beyond remains a mystery, perhaps another supercluster, perhaps the very flow of matter itself bending toward a greater void. You continue outward, rising above this immense network, until you can see the entire supercluster spread out before you. It looks like a living organism, a great coral reef of light. Every galaxy, every cluster, every filament glows faintly, connected by invisible gravity. The spaces between them are not empty. They are the quiet lungs of creation, allowing everything else to breathe. The pattern is breathtaking. Complexity born from simplicity, chaos woven into grace. You realize then that the Milky Way is not an isolated marvel. It is one among countless others, each with its own stars, planets, nebulae, and stories. If you could look in all directions at once, you would see 1 trillion galaxies stretching into forever, each one shining with its own version of home. The universe is not just vast, it is generous. It repeats beauty endlessly, never exhausting its variations. Scientists still debate what lies beyond these grand structures. Some propose that superclusters themselves form part of even greater filaments, connecting through bridges of dark matter. Others believe we've reached the limit of connectedness, the scale beyond which gravity yields to expansion. Beyond that lies the cosmic horizon, the boundary of what we can ever observe. Light from farther regions hasn't had time to reach us since the beginning of time. The universe continues beyond, unseen, unmeasured, unknowable. You float in silence, surrounded by light that has traveled billions of years to meet your eyes. Each photon carries the memory of its beginning, a record of where it came from and how far it has journeyed. In that sense, looking into the cosmos is looking into time itself. The light from distant galaxies shows you the past, the young universe still assembling itself. Every direction is both outward and backward, a journey through space and history at once. You imagine tracing that light all the way back, past galaxies and clusters, past the web and the voids, to the faint afterglow of the Big Bang, the cosmic microwave background, the first whisper of creation. It's a soft, uniform glow that fills the universe, a relic of its fiery beginning. Scientists listen to it like an ancient hymn, a fossil of light left over from when the cosmos was just 380,000 years old. And through all of it, through galaxies and clusters and superclusters, the Milky Way remains, turning quietly in its corner of space. One spiral among billions, yet precious for what it holds. Life, curiosity, wonder. From this distance, it's only a mote of light. But within that mote lies every sunrise, every voice, every dream that ever existed. The scale doesn't diminish it, it dignifies it. You realize that the Milky Way is not small because the universe is large. It's beautiful because the universe is large. Each galaxy adds to the chorus. Each cluster enriches the harmony. The cosmos is not vast emptiness, it's vast togetherness. You gaze for a long moment at that immense lattice of light, stretching beyond sight, and feel an impossible calm. Every filament, every thread, every spark is part of a single grand structure. And in that structure, you made of dust, thought, and starlight belong completely. You hover, for a timeless moment, amid that ocean of light, the web of galaxies stretching beyond what words can hold. It is silent here, but the silence hums with meaning. Every point of light you see, every faint glimmer, is a galaxy with its own stories, its own worlds, its own suns. You are surrounded by infinity, and yet, curiously, it doesn't feel cold. It feels alive. The universe, even in its stillness, feels like it is breathing. As you turn your gaze back toward the Milky Way, that sense of vastness folds inward again. What once looked enormous now feels intimate, a home in a boundless sea. You can trace the faint curve of its spiral arms, see the subtle shimmer of its dust lanes, the golden heart that beats quietly at its center, all of it turning, slowly, gracefully, in a rhythm that has endured for billions of years. You drift closer, retracing the journey you've taken. The great supercluster of galaxies fades behind you. The Milky Way grows larger, more detailed. The Andromeda galaxy glows faintly to the side, its light crossing 2 million years of distance to reach your eyes. You pass through the soft glow of the halo, through the outer arms where stars drift like whispers, back toward the brighter lanes of the galactic disk. The starlight gathers around you again, warm and familiar. From this perspective, the Milky Way feels almost like a living thing. The spiral arms are its arms, reaching, curling, gathering. The bright core is its heart, beating in rhythm with the movement of stars. The dark matter halo is its skin, invisible but protective. The dust and gas are its breath, slow, patient, eternal. And you, every atom, every thought, are part of that breath, woven into its song. Scientists still wonder how long this rhythm will continue. The Milky Way is old, but not ancient. It has many billions of years left before its shape changes beyond recognition, before it merges with Andromeda and becomes something new. Yet even then, it will not truly end. Galaxies do not die, they transform. Their stars continue, their matter reused, their light redistributed. Everything in the universe changes form, but nothing ever truly vanishes. You pass again through the familiar spiral arms, through the Orion arm, where the sun resides, through lanes of soft dust and gas that glow in blue and gold. Below you, open clusters shimmer, nebulae bloom, and the faint hum of the interstellar medium fills the air like a heartbeat too low to hear. You move past the clouds where new stars are born, and you realize you are traveling through time as much as space, each layer of the Milky Way, a different era, a different moment in the galaxy's long memory. You drift nearer to the solar neighborhood once more. The sun appears ahead, steady and golden, surrounded by its family of worlds. Earth gleams faintly in the distance, a fragile sapphire sphere wrapped in clouds and air. You linger there for a while, watching its oceans glint and its continents turn beneath thin veils of weather. From here, the planet looks impossibly peaceful. You can almost feel the wind moving across its surface, hear the hush of waves against the shore. The light that touches Earth tonight began its journey in the sun's core millions of years ago, and the atoms in your body began theirs in stars that lived and died long before the sun ever existed. You are, in every sense, made of the Milky Way, the calcium in your bones, the iron in your blood, the oxygen in your breath. You are the galaxy, aware of itself for a fleeting moment, gazing back at its own reflection. Scientists still marvel at that thought, that out of gravity and dust, chemistry and time, consciousness could arise. That in one small corner of one ordinary galaxy, a being could look up at the night sky and wonder what it means. The Milky Way has produced many marvels, stars, planets, nebulae, but perhaps none as remarkable as awareness itself. For the first time, the galaxy can see its own light. You look once more across the disk of stars, feeling that awareness settle like a quiet warmth. The Milky Way rotates on, its spiral arms drifting through time. Somewhere, new stars are forming. Elsewhere, old ones are dying, scattering their ashes into the dark. Between them, the silence breathes. The galaxy neither hurries nor pauses. It simply is. You breathe with it, in sync. Every inhale matches its expansion. Every exhale mirrors its calm. You begin to sense that this rhythm, this perfect, slow, unending balance, is what peace truly means. The stars do not fear their fading. The nebulae do not rush their births. Even in motion, the galaxy rests. As the view widens once again, the Milky Way becomes a glimmer in a tapestry of light, one among billions of galaxies, each one a swirl of time, matter, and memory. And yet, somehow, knowing this doesn't make it smaller, it makes everything sacred. Each galaxy is a thought, each star, a word, each world, a heartbeat. The universe is not a collection of separate things. It is a single, unfolding story, and you are part of its sentence. You drift in silence, feeling the truth settle around you like starlight. The Milky Way, the cosmos, and you all the same matter, all the same rhythm, all the same wonder. You are both observer and participant, both dust and dream. The galaxy's light will fade someday, but its essence, its atoms, its energy, its pattern will continue, reshaped into new forms. Nothing is ever lost. Everything only changes form. You close your eyes, letting that thought wash over you. That peace is not found in stillness, but in motion, not in endings, but in continuations. The Milky Way is still moving, still creating, still breathing, and so are you. The stars grow softer now, their light turning golden and warm. The edges of the galaxy blur, and the great spiral becomes a single, gentle glow. You can feel yourself slowing, merging with the stillness that underlies all movement. The universe hums, faint and infinite, its rhythm matching your own heartbeat. And in that moment, as the light fades to silence, you understand, the Milky Way is not just where you live, it is who you are. You have always been part of it, its light, its dust, its music, and you always will be. So now, as you drift back toward the quiet comfort of rest, the stars remain above you, not distant, but close, as if watching gently over your dreams. The vastness of the Milky Way no longer feels cold or unreachable. It feels like home wide, luminous, eternal. The galaxy turns slowly, its light rippling across the dark like soft water, each star a whisper, each cloud a sigh. Somewhere out there, a new sun is being born. Somewhere else, an ancient one, fades into silence. The balance continues, unbroken, peaceful. You are breathing in rhythm with it, your pulse echoing the same calm motion that keeps the stars in orbit. The air, or what you imagine of it, feels weightless now. The thought of distance, of scale, dissolves. You are no longer a traveler, but part of the current, floating gently through the Milky Way's endless flow. The galaxy breathes, and you breathe with it. Its light moves through you like a tide. Let your thoughts fade now, like stars disappearing beyond the horizon. Let the universe hold you. Every sound, every movement slows to stillness. There is no hurry here, no urgency, only the quiet assurance that everything, every atom, every spark, every dream belongs. The Milky Way continues to turn, as it always has, as it always will. You drift with it, a particle of its light, a note in its song. The night deepens, the stars grow softer, and peace settles in like dawn before waking. The universe sighs. You rest within it. The galaxy continues to shine, and you luminous, eternal, weightless drift into gentle sleep. Sweet dreams.